What's up, brother?
What's up, dude?
When am I gonna be mod?
When are you gonna be mod, dude? When you stop like losing all your accounts every like 3 seconds,
Oh,
dog.
can my servers back?
Bro, you like? Can I have the swear words back? Maybe. I don't know.
My servers
I
back.
don't know how many times I've given you that permission for your accounts, bro. Like, it just keeps changing all the
I
time.
don't even know. If I were to count, it'd be over 9,000.
It's over 9,000.
Yes.
What's up, Grimmy, dude? Oh, sorry. Let me turn the music off.
Wait,
dude.
wait,
What was
Fuck.
that sigh? What was that with that deep sigh as soon as I joined, huh?
No, I'm just a little tired today, man. I'm still
Dr.
tired from
Gold.
the weekend in Houston, dude. I'm still recovering, man. What's up, Monkey?
Yeah.
What's up? What's up? What's up, Justin? What's up? What do you want to say?
What?
I spent my whole life
Snoop
in
Dogg in the
Houston.
battle pass this
I bet.
season.
No, I don't have time for battle passes. I have to like I have to do.
Snoop Dogg in battle
Bro,
pass.
I don't have time, dude. I know they're gold. I know they're great, but I don't have time for battle passes, man. I just don't have time to
Oh,
play that much of the
God.
game. On God, dude. Grim, how you doing, dude? What's up? I missed you in Houston. It's alright. I'll be back. I'm sure for someone's graduation or
doing
something.
I'm just chilling right now. Just
Okay.
training of it all.
Just vibing, dude. How you doing in school?
I'm doing good. I have an
Good,
100 in pre-calc and like a 80 in for the
That's dope.
Good job, Grim. Glad to hear it,
Yep.
dude. Your brother's doing alright. Ramiro's
Work play later.
what's up later?
Work first, play later. I'm thinking about putting myself on a schedule.
Uh-huh.
You know how I've been working? I'm thinking about putting myself on a schedule for what's it called? For like an hour a day of only
Uh-huh.
computer use.
Okay. I mean that that sounds reasonable. Yeah.
Yeah, and then like I'm also planning to go back to the gym.
Gym is great. I went to the gym this morning. Awesome time.
sir.
Great experience.
I'm gonna once I finish my current nicotine and my current wax,
God damn
quit
it.
smoking until I'm 18.
Yeah. Smoking is dumb, dude. Stop.
Just so I'm 18.
Nicotine's like the dumbest drug too, right, by the way, bro. Like, please don't. Yeah. Like, you guys getting addicted to like Chinese like candy, marshmallow, blast, ice. Like, I don't know, dude. This shit's gonna
You
cause
just
cancer
said
later,
you don't
dude.
got any.
No, dude. Believe me, I have access to them. I just choose to not do them. No. Just don't.
You gotta do one first, and then do two, and then do three.
Oh
and then
my
you
god,
go on the average.
god, no, dude, no. 1 hour mobile use is more effective, ain't it? Yeah, I mean, so my parents used to have a thing where my dad wouldn't let me have the cord to my computer to play for more than an hour unless I had practiced the cello for 30 minutes and like read for 30 minutes or something. Like, so I
1
had
hour mobile use wouldn't really make sense for me because I don't really use my phone that much, only for texting.
okay.
Compared to my computer, which like whenever I actually have free time on it, I'd be spending like hours on it.
Yeah, you
And
got.
I
I
was,
mean, it's
like,
harder,
actually,
dude,
like,
because y'all are
cut down on the
dealing with it
computer.
all the time.
Yeah, cut down with the computer, go up with exercising.
Yeah, I'm here for that, dude. Nice. Yeah, do it up. Here for that. That's a good thing to get into. Yes. Okay. Cool. Let me see. I gotta start the stream here pretty soon, Grim.
Okay.
LMFAO. It's spring break, and I'm on my laptop for 10 hours. Whatever. It's spring break. Have fun, dude. Your kids. Enjoy your life, but when it's like school time, make sure you get your stuff done. Cool. Okay.
Hey, Tatico, how's it going?
What's up, Ethan? How's it going, man, dude? Doing good. Doing good. Another day, another dollar.
Hey,
Hopefully.
Ethan.
Tatico,
Yeah.
yeah, hello. Tatico, I have one thing to say.
What do you want to say, dude?
Do you remember that? It's a question. It's like, do you remember the physics thing you helped me with from converting a velocity time graph to a displacement time graph?
Yeah. I remember that. Yeah. What's up?
Yeah, I finished it before, but I'm not too sure if the last two were correct. Remember, we
Okay.
didn't do the whole thing. You just
Yeah, we did part of it. Yeah. Well, yeah. Send the screenshot and help screenshots, and we'll do it. Is that cool?
I could just, I don't know how you say it, but it's like I could add you to it. Or
could add me to
thing
it?
does not-
Add me. Yeah. Just.
like that.
Oh, at me. Yeah. No. Just dump thing. You know where the channel is. Dump it and help screenshots. I'll get to it because that's the only way I have. That's the only way I have a queue of things to do. Otherwise, like, there's so much going on. Like someone was trying to talk to me like, hey, can I DM you in Discord about like business stuff? I'm like, bro, no. Like, do you know how many DMs I get on Discord? Like, chill. If you need to reach me, like, here's.
Remember when you had so much free time?
I know. Yeah, I know.
We just wasted all that free time with us fighting.
Yes, but it's okay. It helped with your personal development. I'm fine with that, man, dude. It's just that's part of life. It's okay. On God. Okay, cool. Here, let's start off the stream. I can help you guys out with some homework, and we can chat in between. All right. Welcome everyone to Office Hours. My name is Dr. Gold, the Sack Education, the stream that helps you with math homework, science homework, all types of fun stuff. Yeah. Let's see. I need to move this camera. One second. Let me move this camera around. Need to move it like down, maybe. Let me see. That better? I think that's better. Okay, cool. Yeah. I'm experimenting with like camera setups and whatnot, trying to see like what I want to do. Okay, this is I think okay.
All right, I posted the screenshot again.
Good. I like that, dude. Nice. Yes. Awesome. Okay. Yeah. Cool. Today is Wednesday. We love Wednesday. Middle of the week. Last office hour stream of the week. But I'm trying to decide if I'm going to do an AMA on Friday. I don't have anyone scheduled, but it's my birthday too, so I don't know. We'll see. Some chick wants to take me out for lunch, so I don't know. We'll see how long that lasts. So if I get back early from that, yeah, maybe I'll announce like a bonus just stream on Friday. I'll play video games with you guys or something. What's up, Equity? Good to see you, man. All right. Let's see. Equity, your question's first, actually. That's cool. Do yours right now. You ready? Let me know how the I don't know, the mic quality is. You were right, Taco Cat, the other day when you said that my mic sounded weird. It's because my levels like were boosted way too high. I was distorting like crazy actually. So, yeah, let me know if anything's wrong. Like I will fix it. It'd probably show up on Twitch. Yeah. Oh, we got a lot of follows yesterday too. What are we up to right now? How many follows are we at? Let's see. Let's see. Where do I find that? That would be on Twitch. Maybe my stream manager would have it. 840. Whoa. I want to hit 1,000 by the summer. I think we will. I mean, we're already at 840. It's like barely April. Yeah, we've been doing pretty good analytically wise. Here, I'll show you guys. You know, not the most amount of money. I'll take $26, but. But follows have been real good. Yeah, like one of these days we had 14 follows on a single day. So what is this? Averaging about 80 follows every 30 days. So yeah, about 2 months we'll have 1,000. That's cool. I'm a fan. Let's see, Equity, did your thing load in? Yeah, wow. Okay, super high resolution. Let's do it. Okay. Where am I gonna put this? I need to rotate this somehow. Okay. Which one do you need help with, Equity? What's up? All of them? Oh, wow, these are exponentials, actually. These are kind of fun. Weird-ass equations. Yeah, they're pretty weird. Da, 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 da. I'm in class. Can you do my question later? Yeah, totally cool. All right. All good, dude. All good, man. Let me see. Not your friend is here. That he's got a question, or Taco Cat. So, Taco, you ready? Can I do yours? Are you ready, Taco? Yeah. Yeah, I know. Dude, Equity, what are you doing in class, dude? What? It's like 5 o'clock. What class are you in right now? Even if you were East Coast, it'd be like 8 o'clock. Okay, this is a good one. Ooh, I like this. This is actually cool. This is why exponential decay is actually pretty dope. What's up, Nick? I need to download Rebirth. I need to get the new. I hope it's not a massive update. I hope it's like 20 gigs max. If it's like 100, I'm gonna get really sad. Yeah. Half-Life, yeah. One of my favorite games growing up. Do you guys know what Half-Life is? Half-Life video game. It's okay. I'll teach you about it. This is Half-Life. Well, this is Half-Life 2, but for any OG gamers, this is like the original first-person shooter game that came out. Yeah, super cool game. And then Half-Life 2 came out, but anyways. Okay, the half-life of a... So this is interesting. Let's explain like what half-life is. So half-life is the amount of time... half-life, yeah, good. Half-life is when you lose half of an element after a certain amount of time. Yeah, exactly, yeah. It's the amount of time it takes for like half of something to decompose, you know? Recess coming back. Rebirth is coming back, yeah. New camera spot. Yeah, so this is my my prompter that I'm using. Here, I'll actually show you guys. You guys want a picture? I'll send you a picture of what it looks like. It's kind of cool because you're just up here. One sec. Show you a quick little video of what's going on. So like, that's that setup. Then we got that webcam over there, and then we got this, and then yeah, you are right there. So it's cool because I can like read the chat, and it's like I'm looking at you. It looks good. Cool. Nice. Yeah, I'll show it to you guys after this question. But anyways, yeah, so half-life is the amount of time it takes for something to break down in half. So let's say, for instance, I'm trying to think something that, like, deteriorates. Gold, how much money you make? Not enough. Definitely not enough. This was a gift, actually. This prompt, someone bought this for me for my birthday, which is really nice of them. Let me think. Something that, like, deteriorates. That you guys, like, deal with. Let's talk about ice cream, dude. Ice cream, right? Ice cream has like a half-life, right? Ice cream melts, right? So let's say ice cream melts with a half-life. I wonder if it is actually exponential. It probably is. And let's say the half-life of ice cream is I don't know, let's say like 5 minutes, right? So every 5 minutes half of what's there melts. If you're in the chat, like what's your favorite flavor of ice cream? Mine's like anything chocolate. I love like chocolate fudge or like double fudge brownie or something. I'm a big chocolate guy for ice cream. But okay, let's say ice cream melts with a half-life of 5 minutes. That means half of the ice cream that's there will be gone every 5 minutes. And let's say you start with 500 grams, right, of ice cream. And then the question they could ask is like, you know, after 20 minutes, how much ice cream is left? 500 grams is actually a lot of ice cream. That's that's like a pound of ice cream. But I don't know, say you're hungry. So what we can do is we can kind of like visualize this in terms of like a graph. Okay. So if we have something like this, let's say we have, this is like the grams of ice cream. And then let's say this is the amount of time that's elapsed, okay? And because our half-life is 5 minutes, I'm going to do things in like 5-minute increments, okay? So let's do this. Let's say like this is 5, right? This is, you know, I don't know, 10. This is 15. And this is 20 minutes, okay? And then we got to make a little bit of a scale this way. Let's see how I want to make this. Okay. How many we got? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, 50. We can write it with half-life. Yeah, I'll show you how to do it mathematically. I just want to show you guys like numerically how it works first, because it's cooler if you can visualize like why this is. And then the math starts to make a little bit more sense, is what I would say. Yeah. Let's move ice cream. Okay. So what happens, right, when we're starting to eat the ice cream at time equals 0, like this is when I first buy the ice cream from the guy, I got 500 grams. Okay, so that's going to be right here. That's like here. So at time 0, I have 500 grams of ice cream. All right. What happens 5 minutes later? So we say that the half-life is 5 minutes. So after 5 minutes, how much ice cream do you have left? $250. Good. Right? Yeah, it cut in half, right? So after 5 minutes, you're already down to only 250 grams of ice cream, right? So this is 5 minutes, 250, right? Okay. What about after 10 minutes? $125. Very good, dude. Yep. Here's like 125. And then right after 15 minutes, that cuts in half again. So then you got like only like 60. What's up, Amog? You want to talk about ice cream? You can behave. You want to do physics? I mean, yeah, I can do physics. Can you boost your mic? Your mic's like fucking soft dog. Like what?
No, I'm just sick, bro.
You're sick? Oh no. I hope I'm not getting sick. My throat's like kind of hurting today. Yeah.
Nah, I'm gonna pass it to you via.
Okay. Don't pass me the viruses, please.
No.
Don't do it. Oh. Good, right. So yeah, after this, it's 65. Here, let's like write some numbers here. So right, this is 250. This is 125. This is going to be 62.5. And then you can see after 20 minutes, right, it drops in half again. Yeah, good. Yeah, right. So what's that going to go to, Monkey? What's the final amount going to be down here at 20 minutes? Yeah, I know you got to do a little bit of math here. 31 2.25. Yes, good. Exactly, dude. Yeah. All right. So now we're down here. So 31.25. Okay. So this is cool because this looks like an exponential graph, right? Yeah. See how this is like an exponential decay? Yeah. So a lot of things in life follow this behavior of exponential decay, especially like radioactive things. So things like uranium or radioactive isotopes, which we'll go into in your actual question, like why this is relevant. But yes, you can either draw things like this, or there's a way to do it mathematically. So there's a whole equation that they use. Let me see the one that they actually use for this one. It's what is it? It's gonna be blah 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 half-life equation. Yes, where is it? Yes, this is it. This is what it is. Yeah, there's a couple different ways they do this, or they can say like e to the negative gamma t. There's a bunch of different forms for how this gets written. But this is the simplest one. So let's put it. So this is kind of the equation that you use. So you say, right, n of t, this is saying the amount that is there, okay, is equal to the initial amount times 1/2 to the amount of time that has passed divided by how much time a half-life is, okay? So if we wanted to see this using our equation here, right, so n and t is like at what time? So this would be like n of 20. This is not n times 20. This is just saying what is n, like what is the amount that is there, n at t is equal to 20. Another equation with letters, I don't know. Yeah, bro, there's a bunch. Dude, there's a bunch of equations I don't know, man. There's a ton of stuff out there. Yeah, don't worry about it. Yeah, it's okay. It's okay, dude. Let me one second. Let me duplicate this so I make this visible. Yes, and then let's put that somewhere else. One sec. Yeah. Okay. Okay. Right. Saw this question earlier. It looked tricky. Yeah. What's up, Noise? Welcome across the pond. Noise. My parents actually just landed in Cambridge. They landed. When did they land? They landed today. This morning. Yeah. They landed this morning. Pretty cool. Okay. But if we're trying to do this right, then n of 20, right, is going to be equal to what's called n0. N0 is the initial amount. It's the amount that's there, okay? And in this case, right, n0, why are there three different equations? Oh, because these are three different ways to do it. So sometimes they'll do this. Instead of saying 1/2 to this power, they'll do e to the, is what there is. So when they use e instead of 1/2, now you have to use this thing called tau, which is called a decay constant, or you have to use this thing called lambda, which is another type of like delay thing that you have to do. Okay. Cool. All right. Yeah. One second. Let me move this over. Yeah, there we go. I need to turn this one off. There we go. Okay. Sorry, I had the wrong one selected. No, let's put that over there. One second. I gotta move this webcam over. Lock that. Yeah, and then let's move you over. There we go. Yeah, I could have multiple Dr. Golds. Look at this. We could have Dr. Gold over here and Dr. Gold over here. I have to, yeah, there you go. Okay. Okay, cool. All right, so, when doing this, n0 is the initial amount. That, in this case, is 500. And then we have 1/2. And then t, this corresponds to the same t that you're trying to find it at. You're trying to find the amount at some time t. In this case, we wanted it at 20 minutes. Okay, so that's going to be 20 divided by the half-life time, which in this case, t1/2, we said was 5 minutes. Okay, so this now becomes the equation, which is just 500 times 1/2. 20 over 5 is to the 4th, okay? So this becomes actually, this is kind of cool. You can do this in your head because and you should know these. Like 1/2 to to the second is a quarter, it's an eighth, and then it's a 16th. To the fifth is a 32nd. So yeah, this whole thing becomes 1/16. So it's just 500 divided by 16, which, you know, if you did this on a calculator, it's not too bad. Let me find. Where's my calculator? There you are. Come here, calculator. Yes. Okay, cool. If we do 500 divided by 16, that just gets us 31.25, which was the amount of ice cream we had. Cool? So, yeah, let's try to actually do this with the question you were talking about, which is with carbon dating, actually. It's called carbon dating. No, it's not like Tinder for carbon. It's a way of figuring out when things have like died. Yeah, in this case they're saying a substance X. Usually it's carbon. Carbon 14. Okay. A sample is taken in which it contained 1.5% of X and 13.5% of Y by mass. If substance Y is not normally found in the meteorite, what is the approximate age of the meteorite? Okay. Very cool. It decomposes to substance Y. Okay. That's cool. You have an electric system. Okay, cool. Yeah, bring it up. Yeah. Okay. What we have to kind of figure out here. So anytime they give percentages here by mass, the trick here, Monkey, is to just assume that there's 100 grams of it, and I'll show you why that makes sense. So I'm gonna assume, because they say by mass, because what happens is you have some substance. This is the meteorite, right? This time okay, well, yeah, please go to uni, dude. please, yeah, take it seriously. Yeah, no pints before your exams, please. I did this noise actually myself when I played that show on Friday, which was like super. It was the biggest show I've ever played. It was like 1,200 people, biggest DJ I've ever opened for, and all my friends were like trying to get me to do shots before like I went up, and I was like, no shots until I'm up there, please. Like I take things like those seriously, and you have to yeah, don't impair yourself right beforehand, please. Like get a good night's sleep. Okay, so this is like the amount of X, and then this is the amount of Y. Okay, and what they're saying here, Taco, right, is that as this meteorite ages, the amount of X here, right, the amount that's here is going to decrease. The percentage of the meteorite that is X will decrease, and it will transform into an amount Y. So it's gonna like move, right? And they say this is like percentage by mass. So it's like out of the total mass, this percentage of it is Y, or this percentage is X. So when I see these types of questions, the first thing you want to kind of do is assume that there's 100 grams of it. So we're just going to do this. We're going to say, assume 100 grams of meteorite. Okay. All right. So that means, right, if we have 100 grams of meteorite and 1.5% of it is X and 13.5% of it is Y at a certain time, how many grams do we have of each? Like, how many grams of X are there if 1.5% of it is X and there's 100 grams total? Good, 1.5. Yeah, this is why we pick 100, because it's a nice number. You just get rid of the percentage, right? Okay. So we know, like, at time t, right? X is going to be equal to 1.5 grams, right? Or at time, well, yeah, we don't know the time. We're trying to find the age of the meteorite. So at some time t, X is 1.5, and Y is going to equal to 13.5. Okay. But we want to figure out, okay, we have to figure out the age of the meteorite. So I think we have to kind of know like how much this started with, right? Okay. So let's because what's happening is the amount of X is exponentially decaying, right, by a half-life. But the amount of X that decays is the amount of Y that gains. So it's actually weird. So this is a very unique question. Because it's not just a half-life decay. There's also like a growth part to it. Okay. So, And whatever the half-life is for the X amount to decay is the amount of Y that grows. Yeah, it's actually, yeah, this is actually kind of weird. All right. And okay, oh, but here's the cool thing. They say that substance Y is not normally found on the meteorite, right? That means so when this meteorite was created, when it started, there was no substance Y, okay? So we know that. So we know at T equals to 0, right? The amount of Y is equal to 0. Right? There's no Y because this is not natural. And here's the cool thing, right? So if the amount of X and the amount of Y at the end is 1.5 and 13.5, and then at time 0 there's no Y, how much X is there? Assuming that we're going to go by conservation of mass here too, by the way. I'm going to assume that the total amount of mass does not change. Right, there was 100 of the meteorite, right? Okay. But what about the amount of X there, right? Okay. So look here, right? So what happens is like X decomposes into Y, okay? So if I start with 100 and I have 0, and then suddenly I have, let's say this decreases to, let's say 60, how much Y has been made? If the 100X has decreased to 60, how much Y do we now have? Good. Yeah, exactly. Right. Yeah, do you see here? Do you see how the total amount is always the same, right? It's 100 and 0, or it's 60 and 40. But the total amount of X and Y is the same. It's the same thing here, Taco, right? So at some time, I have 1.5 and 13.5 of the X and Y. But at the beginning, I know I have 0 Y. So how much X do I have at the beginning? Try to maybe look at, do you see how like the totals have to be the same? $100. Yeah. Yeah, so that was here. But look at this. Do you see how this is 1.5 and 13.5? So here, it's going to be 1.5 plus 13.5. This is going to be 15. Good. Exactly. Yeah, very good. Okay, nice. Yeah. Okay. So now that we know this, now that I know that, like, okay, I started with 15, I now have 1.5. Now I can use this equation to figure out how much time has elapsed. Okay. So here's what I'm going to say. I'm going to use this equation, right? I'm going to say n of some time t is equal to my initial amount. What's the initial amount of x that starts? Yeah, 15. He got C. We'll see, Noise, right? It's okay. It's okay. Yeah. So talk. Oh, you didn't hear me? Okay, tacos. Yeah. It's okay. So the amount that you started with, that's n0, right? That's 15. And then it's 1/2, and then it's to the t over t 1/2. What's t 1/2 here? What's the half-life of substance X? What does it say in the question it is? $7.5? Where do you see 7.5? I see 45 up here, right? It says the half-life is 45. So this is going to be T over 45. No? Okay, so T 1/2. What's up, Amog? You saying, dog?
I'm just ranting about sig figs.
Okay. Dude, fuck off the sig fig. Yeah, Taco, look. Okay, so for this equation, right? This is the amount you start with. This is just a half. This is the amount of time that has elapsed. This is the half-life. The half-life in this case is 45, right? So yeah, that's going to be 45 there. Okay, cool. So yeah, and then the amount, right, at this time t that we're going to figure out, right? That's going to be 1.5. So this new amount we're looking for is so I know there's 1.5 at some time t. I'm trying to figure out what that time t is. And I have the rest of the part of this equation here. Yeah, okay, cool. Okay. So 15, this might be like easy to solve. We'll see. T over 45. Okay. Again, so now this is algebra. Which again this is why it's important for you guys to learn algebra and like not forget shit, because you have to keep doing it. What is t? T is the amount of time. So t is the amount of time it takes, Taco, from it to go from having, 15x and 0y to this new time where there's only 1.5x and 13.5y. We're going to solve for it. We need to solve for what that time is. That's in this question here, right? It says, what is the age of the meteorite? That's saying how much time has elapsed, right? How old is this thing? Such that when it was new, it had 15x and 0y, but now it has 1.5x and 13.5y. Okay, good. You see it now? Awesome. Perfect. Good. Okay. So this is what we're just solving this at this point. So this is an algebra trick, okay? I need to try to get this t, which is up here in the exponent, on a side by itself with no numbers attached to it, all right? So what I always like to do, guys, when I see this is, again, look for the number that's furthest away from this and do the opposite thing to it, right? So what number is furthest away from the t? That's on this side, at least. The 15, good. Now, the 15 is multiplying, so what am I going to do to each side? Dun, 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 dun. So 15 is multiplying, Taco. 15 is multiplying by here. What's the opposite of multiplying? It's a useful thing to know. Yeah. Come back, Taco. You make me cry, dude. Divide! Yes, good. Thank you. Okay, thank you. Yes, divide. Yes, you're good. You're good, dude. Okay, so divide. We're going to divide by 15. Okay. 1.5 over 15. You should see how these are basically the same things. You see I have like a 1/5 and a 1/5. This is the same thing as 1/10. What you could do is you could say, I'm going to divide this by 1.5. I'm going to divide this by 1.5. And 1.5 goes into 15 because you just move the decimal. It goes in 10 times. So this is just going to be equal to 1/10. Okay, so now I have 1/10 is equal to 1/2 t over 45. Yeah, so now this is a little tricky, all right, because I have to get this t down. Yes, so we are going to use logs. Because again, here's the rule. If you got log of a to the b, this is the same thing as b log a. Okay? Like this just comes down. That's what happens. Okay? All right. So if I take the log of both sides, I'm going to do this. I'm going to say log of this thing is equal to the log of this thing. Okay. Now this exponent, right, this thing up here, is going to come down out front. So this whole thing here, we're going to take it, and it's going to come over here, right? Makes things nice. And here, we can move all the log stuff over. Let's move it over. Okay, sweet. Okay. So, and that's a trick. That's a trick y'all should know. It's how to pull like variables out of exponents. So now I can just divide this on the other side because this is just being multiplied by it. So we can do this over. Okay. And then now we have this whole thing right here is equal to t over 45. So we can multiply both sides by 45. Okay. So that goes away. And this is my final answer. So t is equal to 45, the log of 1/10 over the log of 1/2. This you need a calculator for. I don't know if I can do this in my head. So what is that? 45 log of 1/10. That's 0.1 divided by the log of 0.5. Okay. That gets me 149.48. So that's about let's say 150. Okay, so let's check. Let's see. Is that an answer choice we can have? Okay, approximately. So 149. Yeah, it's close to 140. So yeah, I would say answer C, which yes, I mean it's close enough. And yeah, that's what Noise got as well. So yeah, that's good job, dude. Good job, dude. Good question. Yeah, that was a good one. Nice. Yeah. Hope that's cool. Let's see. I know here, Noise, let me do your question. You didn't do it with the equation? How'd you not do it with the equation, dog? You saw it went down by a factor of, what is it? 15 down to 1.5. So, okay, I think I see how you did. You did it in your head, right? Did you do this? Yeah. Oh yeah, dude. Yeah. Okay. What's that having time question again, Jeff? What is it? Rule of 74? Rule of 82? Cough. Rule of 72. Yeah. Oh, the way that's for percentage and interest. Oh, I see. But yeah, okay. So yeah, right. 15 to 7.5 to 3.75 to basically 1.5. So that's 1, 2, 3. That's like three half-lives almost, right? Which, yeah, 3 times 45 is around 135. So yeah, you could get it. Yeah, you could get it. Yeah, rule of 72. Yeah, thanks, Jeff. It's a good rule. Nice. Yeah. I this was good to like show, because I always like to show the kids like how you can deal with like trying to figure out how to pull variables out of exponents and stuff. But yeah, that's another good way to do it. Okay. Here, let's see. Let me do Noises first next, just because he lives in the UK and it's really late for him right now. So let's see, Noise. Ooh, this is cool. The diagram shows a uniform electric field strength of 15 volts. The length RS is perpendicular to the field, and the length ST is parallel. What is the change in the electric potential for a charge of 3 microcoulombs moving from R to T? Okay. Wait, oh, okay. No, you're good. No, bro. It's fine. Okay. So, change in electric potential energy, is that the work done? I think that's the work done on an object, right? I think that's the work. Like, change in potential energy, whatever. It's probably like some form of work due to a potential force. So here's the important thing, right? So if this thing is moving from R to T, okay? Remember, if the electric field is pointing this way, right? That means that moving across it this way does not require any force. Right? Because there's no force, there's no work, so there is no change in electric potential energy due to moving in this direction. No. Okay? All we actually care about is this, right? Okay. So, okay, so F, right, is equal to QV. Or not F is equal to, I think work is equal to QV. Is that what it is? F is equal to QE. One sec. F is equal to QE. And then E is equal to, I think, V over D, or E over D is V? Yes. E over D is equal to V. Oh, okay. So watch this. This is actually cool. This is actually kind of cool this works. All right, so this means that, yes. Okay. So V times D is equal to E. So I can replace this with VD, right? And then, is that what it is? One sec. I'm forgetting my electrodynamics. Electric field. One sec. Yeah, E is V over D. F is equal to QE. Yeah, thank you. Yeah. I had that wrong. Oh, I should have seen it from here. The electric field is volts per meter, right? So that's volts per meter. Thank you. Yeah. Yep, very good. Yeah, this is another cool thing, Noise, in physics. If you can figure out the equations just looking at the units. I knew electric field and voltage and distance were related somehow. But yeah, that's the electric field. And then I know F is equal to QE. This is a good one you need to know. So if I plug this in, right? Do you see how I get QV over D? And then let's move this over, right? So this is just FD is equal to QV. And then remember that a force times a distance is an energy, right? That's work. Work is a change in energy. So I think the work done to move a charge is just Q times V. So wait, is it not dependent on the distance then? Really? It can't be that easy. Yeah, there's got to be some distance to it too. It's really say Q. Oh, okay. My bad. Sorry. Work is equal to QV, and then V is equal to ED. Okay, this is what I did a roundabout way of doing this. Okay, there we go. QED. This is what I wanted to say. Noise. Okay, so the work required is QED. Yeah, we don't even need to deal with potential at this point. We're not doing anything with potential. This is potential energy, which is different. So it's the charge times the electric field times the distance, and it's the distance and the electric field have to be in the same direction. So the distance this thing moves is technically diagonal, but I only care about the amount that works in this direction because that's the same direction as the electric field. So it's just going to be this 3 times 10 to the minus 6 times 15 times 3, right? Okay. So what is that? That's 45 times 3, so that's 135. So it's 135 times 10 to the minus 6. Okay, so the answer should just be A. Is that correct? Quad error demonstratum. Yeah. No. QED. Yeah. No, wait. Where's Penn Center? Penn Center's doing something with like what's it called, like QED giveaway or something? What is a QED giveaway? He was telling us in his stream. Yeah. It looks good enough to me. Okay, cool, nice. Yeah, sorry. I had to struggle a little bit with I haven't done E and M in a bit. Yeah, so I have to remember all the equations, but yes. In general, the conceptual thing here you want to remember, Noise, is that moving perpendicular to electric fields does not require any force. So there's no energy and there's no work. Yeah. Okay, cool. Yeah, good luck, dude. Good luck on your exam. When do you have your exam for this? This is your A levels? Are you doing your A levels in this or something? What's going on? Here, what, Amogi, do you got a quick one here? May, June? Okay, yeah, good luck, dude. Yeah, best of luck with it. You're gonna do well, man, dude. I know you will. You're a smart kid. Alright, what's...
Is not making sense.
This isn't... Okay, this is easy, dog. I can answer this in like two seconds for you, bro, dude. What? Okay. Okay, frequency and wavelength. Okay, cool. Man, what are all the equations for this? It's okay. So
I have them. Do you want me to send it?
No. I know what they are. I just need to remember. So period, right, is 1 over the frequency, right? Do you know this one?
Yeah.
Okay. So we have the frequency, right? And it's in water, right? So you just do 1 divided by that, right? Isn't it just 1 divided by? You did?
Yeah.
You sure? Well, let me make sure you're doing it.
I got 8.695. You round to sig fig, so 8.70.
Did you put the right exponents on it?
E5. Sorry, E6, right?
It's it's E6, so when you divide, it's going to be e to minus 5, I'm pretty sure. Or so, okay, there you go. You get 6.67 times 10 to the minus 7. Or, sorry, no, 1.15. My bad. 1 second. Give me a second. Sorry. Putting the wrong fucking numbers in today. Okay. Yeah. 8 point... How many decimals do they want?
3 because it's 3 sig figs.
Yeah, so 8.70. This should be 8.70 times 10 to the minus 7.
Okay,
that-
I'm just being slow. Thank you.
It's okay. All right, and I assume you can do this one. Do you want to do this?
How do we do air?
Interesting. Okay. A sonar signal of that has that in water. Well, there is the speed. So the speed of sound does change in different materials, right? So here's what we say. So like, speed of sound in air, I believe, is 343 meters per second. What is it in water? One sec. Speed of sound in water is 1,500 meters per second. Okay. Maybe okay, I think the frequency doesn't change, but the wavelength does. Yeah, because it's denser water? Yeah, I don't know. Well, yeah, again, that depends on temperature. This is a physics question. Again, I don't like waves. Whenever people ask me to like tutor them in waves, I'm just like, I don't like waves, man. Like, waves and optics are like my bane of my existence. Let me see. Period of wave in air versus water. Yes, good. Okay. Yeah, it doesn't change. Yeah. Yeah, okay. So it's the same. It's the same.
Same
So,
answer?
It should be the same answer, yeah. So the frequency does not change, but because the speed does, it's the wavelength that changes. Right, so waves have, they have a
you're right.
speed. Yeah, and then they have a wavelength. This is if you're looking at this as a snapshot and you're looking in what's it called, like K-space, like, yeah, distance stuff. Yeah. So, yeah, when this thing is in air, the wavelength is going to change, but the frequency does not. And that has to do with, like, the amount of particles that are in a medium. So in air, you don't have that many molecules next to each other to carry the signal, and that's why the speed is slower. But in water, you have a bunch of water molecules right next to each other, and so they're able to bump into each other, so that's why the speed is faster. Yeah. Yeah, cool. All right, good question, dude. Nice.
It's so much different than chemistry.
Yeah, I mean, physics is cool. I mean, I don't like waves per se, but it's cool stuff. Wait, how many accounts do you have here, dude?
Difference.
you-
Probably just my friends.
Oh, okay. They call themselves as Moog as well to just mess with you, bro?
Oh, that's my friend's alt. See, like,
Oh,
okay, there's a whole story to that. I'll explain later.
okay, you're a Mogi Wogie, though. Okay, cool. Noise says, waves are awful. Interference with double slit experiment and path difference and all crack is possibly my worst topic, bar thermodynamics. Yeah, thermodynamics is like a pretty tough subject for me, at least. There is one book that saved me on my graduate school comp exam for thermo. What is it, dude? Thermodynamics. I think it's firm. Yeah, dude, here it is. This is it, bro. Okay. If you want to understand thermo in as quickly as possible, no bullshit, no whatever, it's written by Enrico Fermi. Enrico Fermi's who like came up with, if you watched Oppenheimer, Enrico Fermi is the guy that came up with the atom bomb, basically. Him and Oppenheimer and everything. But yeah, this book is a godsend, and this is what really got me through got me through my comp exam, so I was able to do it. I probably have a photo of myself with this book. One sec. If I look up Gandalf, I think Gandalf is in there. It's like I probably got a picture of him somewhere. Yes, dude. Okay, here. You want to see? This is a young Dr. Gold in, what was this? Yeah, 2013. So this is me like trying to study and pass my comp exams at UCLA, and there's the book. There's the Enrico Fermi book that I used to teach myself thermo. It's and I was asking Gandalf at this point if I could pass. You know, the you shall not pass. Spoiler, I did pass, fucking barely, but yeah, I passed my comm exams. But that book helped with thermo. So yeah, highly recommend that
I
one.
posted the difference between chemistry and physics for me.
Oh, is it? Let me see.
That's physics, the top one.
Oh god, so that's an 89 versus 101. Wow. Well, you know, if you need help with physics,
Also,
man,
like,
dude, like,
No, it's because I have like 10 missing assignments.
oh well, yeah,
can
do
see
your
that.
don't miss your assignments, dog, please. Yeah, do your assignments, dude.
No one brings it up to 95.
Oh, okay. What's this thing that Noise is showing me to? An opening paragraph to God Science states, Ludwig Boltzmann, who spent much of his life studying statistical mechanics, died in 1906 by his own hand. Paul Ehrenfest, carrying on the work, died by 1933. Now it is our turn to study stat mech. Yeah, bro. Yeah, stat mech is brutal. Again, but that Fermi book is great. Fermi's great. Yeah. I'm trying to think. What was the other thing you were asking for? You were asking about yeah, the gas laws are in it. Yep. And interference patterns. Yeah, I forgot who that was. Yes. Not your friend is here. Cool. All right. Yeah, I think your question was next. Let's go to yours. Did you give me a challenge question, dude? You probably did.
Hey, Dr. Gold.
What's up, Ethan?
You know you said that last week, the last time, you remember that you said last week that it was the last time we played Doors, right?
That was we did play Doors. Yeah.
You said it was going to be the last time for the tournament, right?
We might do some more. You know, I feel bad that I was out last week. I wasn't able to play more games with you guys, so I might do like some double headers this weekend. I'll announce them. Sorry, I'm still trying to recover. Thursday, I'll announce all the new tournament rules. We're gonna have a talent show coming up, a bunch of stuff. Yeah, I want to finish it out because tournament ends in 20 days, I think, 26 days. Yeah, I got to give a PS5 to somebody.
Hey, Dr. Gold. I need to tell you something.
What's up, dude?
I was just playing Doors, and they actually did something for an April Fool's update.
Oh, did they? Oh, that's fun. What'd they do, man?
Yeah, apparently they actually added in voice lines for whatever you do. Like, what items you pick up, what doors you open.
Okay.
Even for the monsters, they added voices.
Oh, they added voices. Oh, that's cool. Are they like funny voices? What do they do?
Kind of. They basically just say random stuff. No cursing, by the way. There's no cursing in them.
Oh, that's good. Yeah, we don't need any cursing. That's all good. All right, here. Let me do not your friend's question. We're going to do triangles. Yeah. Jeff, I need your help, dude. Because I know I'm going to get kind of screwed on this one, probably. All right. A is the right angle. So this is the right angle of the triangle. E is the midpoint of AC. Yeah, dude. Yeah, what's going on here, dude? Right. Yeah, Jeff. Help me, Jeff. The perpendicular drawn to AC at E meets DC at B. Okay, so we got this. Okay. I'm supposed to distract you. Yeah, it's okay, Jeff. Maybe this isn't too bad. Draw a diagram, indicate the above information, and show that bad, okay, is an isosceles triangle. Oh, okay. They want to show that this imaginary triangle is an isosceles. Oh. Okay, let me make this like dashed. Let's like make our life a little easier. Okay. Huh. A lot of stuff going on here. E is the midpoint of AC and the so okay. So this is called the perpendicular what is this? This is called an altitude, maybe? Sorry, what's the name for this thing called, dude? When it's like the perpendicular to the triangle, but it's like is it called? It's called the perpendicular bisector. I think it's a perpendicular bisector or altitude. Yeah, okay. Is there some rule where this splits this in half? Oh, it definitely splits this in half, right? We know that. Yeah, no, yeah. I think this is the altitude technically. It's a perpendicular bisector. Okay, so yeah, so this is definitely gonna split. Right. Okay, and I know this is equal to this. Okay. Yeah, the altitude drops from one of the points. Yeah, I agree. Yeah, I think like this is an altitude technically. Oh. Oh, okay. Well, okay. We're kind of already okay here, right? Because this is this so BE here, right? Right, not your friend. This is congruent to itself, right? And because I know this splits it in half, right? This is congruent to this. And then because I know that's perpendicular, it's a 90-degree angle. So we already have what's called like side angle side, right? So I can already say that this triangle is equal to this triangle, right? Or at least, wait, can I say it's congruent? I think I can say it's not. It's more than it's similar. It's congruent. I'm pretty sure. Yeah. So these are congruent triangles, okay? Which tells me right away that what is it? That this is equal to this, right? If these are congruent triangles, okay. Yeah, but I want to prove this is isosceles. Which means I need to prove that this is equal to this. Which would be nice if I could just prove that, you know, this cuts the whole thing in half. Oh, which I can. Oh, very cool here, actually. Okay. So. Yeah. No, yeah. Well, okay. Well, here's the other thing I can say, right? Okay, so this triangle, right, is inscribed within this triangle. Right? And since this length of the triangle is half of this length of the triangle, that means that this length is half the length of this length. That's just from inscribed triangles, right? So, yes, I can say that this is also this. 1, 2, 3, 4. Yeah, okay. Okay, and then by this definition, okay, cool. We got two sides. It's an isosceles. Yes. Great. Okay. Other part. Show that AC squared. You have 5 marks on BC. Did I put 5 on BC? Oh, 1 too many. Yeah. Thank you, Jeff. Yes, thank you for. You're right. Yeah. I was doing like the color and the marks. Yeah. Okay. All right. Show that AC plus AD squared is equal to 4AB squared. Oh, that's easy. Okay. Well, okay. So, yeah, okay. So, AC squared plus AD squared is equal to CD squared, right? We know this by the Pythagorean theorem. And you have nothing with a single mark. I like it. Yeah, I was saving the single mark for something special. So, right, we know this. This squared plus this squared is equal to this squared. Pythagorean theorem. Awesome. Great. Cool. And then we know, right, that CD is equal to 2 times AB, right? Because AB is equal to BD, which is all equal to CB. So this whole thing is 2 of these. Okay, so now this just works, right? Because if I just throw this in, right? AC squared plus AD squared is equal to 2AB, all of that squared, and then this whole thing becomes 4AB squared. Nice, and that's the correct answer. Awesome, dude. Hell yeah.
That's dope.
What the hell?
It's Chewbacca, dude. Chewbacca's here, man. I was going to set up a coordinate system. Your way is much better. Yeah, it's fun. This one wasn't too bad. This is kind of like a fun little puzzle. Yeah, nice question. Not your friend. Good. What up to the 20 viewers in Twitch? Yeah, if y'all got any math or science questions, you know, there's our Discord. You can go join it. And submit questions, and we'll go over them here live on the stream. Or you can like keep lurking and just, you know, watch us do questions. It's also cool. Actually, both those links work. What up, Obama? What's good?
Yo, when you took the SAT, how long was it?
Like 5 hours, 6 hours, probably. I don't know.
5 hours?
Fuck, I don't know, dude. Maybe 3. I don't know. That was a long time ago, bro, dude. That was I was probably 17. I was half my age I am now, dude.
Bro, I took it today, and it was only like 2 hours and like 30 minutes.
It's on a computer now, isn't it? Right? You take the SAT on a computer. Yeah, we have pen and paper, dude. Does this also mean you get the? Is there an essay component to the SAT where you just type it?
No, they took it out. They took it out.
Good, because that thing was garbage, dude.
Just multiple choice, and it's the easiest questions ever.
Yeah. Okay. How's your was it your pre-calc going, dude?
What do you like? This quarter?
Yeah, well, I was helping you yesterday on something, wasn't
Yeah, I still have a 90 now.
Okay,
Grade
good.
point dropped really low.
I? Oh,
Like, it
good,
just
dude.
dropped below a 93.
Dude, hell yeah, dude.
That's dope.
Jeff's got a question. Jeff, you've been chilling in the chat. Let's go through yours. You're probably gonna teach me something here, Jeff. Okay, and then I'll do more of the kids' questions. Okay, here we go. All right. If I have two functions f and g such that fx1 y1 is less than fx2 y2, if and only if gx1 y1 is less than gx2 y2, is there a name for a relation between f and g? Oh, okay. So let me try to draw this. So let's say this is x and this is y. And so I'm just going to say that whatever this value f of x, that's like the z coordinate is what it is. Like if I want to compare the length of two vectors, I can just compare the norms squared instead of computing the norms. As long as everything's not imaginary, I guess, right? Because imaginary is only instead of just computing the norms. Okay. You say yes, 2D vectors. Yeah, okay, yeah. So you're saying, for instance, if I have 3, 4, right? Versus, I don't know, 2, 5. We'll see if there's a counterexample to it, right? So calculating the norm of this, right, would just be the square root of 3 squared plus 4 squared. And then that's versus the square root of 2 squared plus 5 squared. And you're saying, can I just square both of them and then compare them instead of comparing what the square root is? Ooh, what if they're fractions, though? Wait a minute. Yeah, because square roots, it's faster not to square root. Yeah, but square roots do weird things when we get lower, right? So, for instance, the square root of a quarter, right? That's 1/2. That, boosts the number up, right? But if we have the square root of 4, that's equal to 2, so that takes the number down. I think this works because square root of x is an increasing function. Yeah, but not yeah. I don't think exactly so here though, right? Okay, yeah, because so here's my counterexample, right? Let's say I have something such that x squared plus y squared is equal to a quarter in one case, and then let's say I have x squared plus y squared is equal to yeah, okay. Well, that's gonna boost it up, but you're right. Any fraction is taking the square root of it is it's not gonna boost it up or down by enough. One sec, I think. Yes, okay. Yes, yeah, it's not greater than x ever, but it is non-decreasing. Yeah, exactly. Yeah, you're talking about this. Yeah. So the rate at which it increases, yeah, changes, but it's always increasing. Yeah, it's non-decreasing. Yeah. What's up, G-Man? What's up, Equity? Yeah, okay. Yeah, I just know it's weird. Yeah, another great example. If you want to compare great circle distances, you can compare the straight line distance because the great circle distance is 2 arcsine the length of it. Dude, excuse me, what's a great circle, dude? I need to look this up. Great circle? As opposed to the not great circle? Is the shortest distance between 2 points. Oh, this is cool. So this is how they do flight paths, right? Oh, this is super cool, man. Yeah, okay. They're saying, yeah. So this is why, for instance, when people wonder sometimes, here, let me say great circle distance flight paths. Yeah, very cool. Yeah, That's a cool article. Yeah. So, like, again, yeah, if you were to look on a map, right, and you were trying to go here from Washington, D.C. to, I don't know, Madrid. Madrid is great. It would look nice to just go in a straight line. But because you're on, you know, a curved surface, actually taking, like, a dip up here is shorter. Wow. Yeah, because straight line distances are not the same in a two-dimensional map as they are on a three-dimensional globe. Ah, this is cool stuff. This is stuff that Hypatia is really good with. Hypatia does a lot of, like, no flat map can show the great circles as straight lines. Riemann mapping theorem. Yeah, that's cool. I didn't know it was called Great Circle. That's cool, Jeff. Yeah, this is like ridiculous, right? It's just like, what if I want to go from here to here instead of just going straight across? I do this like really wonky like line over. Yeah. Yeah, or this one is yeah. Anytime you're going from, one sec, what is it? Open this in a new tab. Yeah. If you're going anywhere from the West Coast and you're going to Europe, right? It looks like you would just do this. But in reality, you end up Chicago to Tokyo goes across the North Pole. Oh, really? Yeah, well this looks like it almost goes across the North Pole. You do this all the way. Let me look up. Chicago, Tokyo, flight path. Okay, yeah. Yeah, that's super cool. Yeah, okay, I see. Wow, look at this. Yeah. Yeah, you do almost go over the North Pole. Wow. I did that once when I was it was in grad school. I did Los Angeles to New York to Europe to Prague to Tokyo and then back to LA. I went all the way around the world in like 2 weeks. Through a series of flights. And I think the flights only cost me like $400. It was one of those really random like price mistakes, I guess. It was a great time in my life. I think everyone should do that. Everyone should travel the world at some point and do it when you're younger because there's less responsibilities with things. Do flights go near the poles for a reason? It's because, yeah, there's less distance equity. Yeah, exactly. Yeah, exactly. That's why it is. Gold, I'm being slow again. All right, I'll do your question in a bit. Let me do equities. Hey, that's a cool question, Jeff. I learned something today. I always appreciate when I learn things. Yeah. Nice. Bum. My bad, Gold. I had class. Sorry about that. That's okay, dude. Nothing wrong with having class. Like, you're okay having class, dude. Where was your question? Was this one? Let's do this one too, because I don't want to do this. Yeah. Okay. All right. Which one do you need help with, dude? There's a lot here, but you just tell me which one. Maybe pick one. You can pick the hardest one if you want, and I'll do it. It's fine. Anyone you want? Okay. Cool. All right. All right. Let's do this one. Okay, let's do this. Okay. All right. Okay, so yeah, this looks weird, right? So I always like to try to think like what's the parent function with this one. Okay. Yeah, Saint, I'll ping you. Yeah, I see yours, Saint. I see yours. Yours is probably close to being next. Yeah, you're good. And then Cuber wants to learn the Pythagorean theorem. Yeah, we'll teach Cuber the Pythagorean theorem. Okay. Okay. So, f of x is that, all right. I like to try to think what the parent function is. So in this case, I think the parent function, just try to like strip as much weird stuff that's happening, okay? So I think the parent function for this f of x is just equal to, it is really just e to the x. Yeah, but let's just say it's 1/2 to the x. Let's just say it's 1/2 to the x. Yeah. I know it's true parents are probably, you know, e to the x, but yeah, let's just say it's 1/2 to the x. Okay. So let's look at like all the different things that are happening to this, man, because there is a lot. There's a lot. Okay. So and then we can kind of learn from from all the transformations, like what's happening. Okay. So first I'm gonna look at like what's happening up here at the x first off, right off the bat, right? So I see that x is being divided by 4, right? So this is really okay. Cool. There's a divide by 4 happening, right? Okay. And so that's gonna end up. So do you know what that one is, Equity? Do you know what's gonna happen if I end up like dividing the x directly by 4? Like if we do f of this is kind of like f of ax, right? I had an image of all these. What was it? Graphing transformations. Yeah, this is it. It's a horizontal stretch. Yeah, it's a stretch. Yeah, it's a weird one, right? Usually division is like a compression. But that's this one classified down here, right? Yeah. And because we're multiplying by a fraction, we're dividing by 4. This is a stretch. Okay, so cool. So right up. I'm going to say like, let's write on the right here what happens. Okay, so we have stretch. And what you always want to do is you want to look at what's happening first to it and then kind of expand outwards. So first we take the parent function and we stretch it horizontally by 4, okay? Then the next thing is that there is a minus 3/4, right? So now I got minus 3/4. What's that minus 3/4 going to do here, right? That's going to be this. What does minus 3/4 do to it? Good, yeah. It's going to shift it to the right by 3/4. And again, horizontal stuff is always backwards, right? So minusing now puts it to the right. Okay, so we're going to say shift right by 3/4. Okay, cool. All right. Okay, so that's right by 3/4. Okay, so then let's look at what's happening next to it. So then I go down here, right? And I see that there's a 1/2 also being multiplied on the outside. Okay, so that's gonna be a 1/2 over here, right? And even I'll kind of well, okay, no, we'll do it separately. Okay. All right, good. Yeah, you're good, Mo. Just come back when you get back. All right. So that's a 1/2 that's happening outside of like the whole parent function. So that 1/2 goes outside the f of x. So that's the same as here, right? You see how that's outside the f of x. So that's gonna be what is that? That's a vertical shrink. And this is where it's opposite to the horizontal stuff. Like, and this, it makes sense, right? Fractions should make things smaller, but vertically, yes. So shrink by 1/2. Okay. And then there's also, I'm running out of colors here. There's a minus sign, right? Do you see how there's a minus sign up here? That's going to put a minus up here. So what's the minus sign going to do? Good, yeah. Vertical reflection. Yeah, good, exactly. Yes, reflection over the x-axis. So that means it's going to reflect it over this axis. Okay. So then we say x-axis reflection. So reflect. You can sort of cheat by pulling out the 1/2 to the minus 3/4 as a constant. Yeah. Yeah, you're right. I could. Right. Oh, because of this. Yeah. I'll explain that. Yeah, I'll explain why that is. Yeah. Yeah. That's actually kind of cool. That's the math hacks. Yeah. Okay. Final thing that happens, right, is that I have this -1. So we have a -1 over here, which is the same as a -1 outside the f of x. And what is that going to do? Down 1. Yes. What's up, Teacup? Good to see you, Teacup, dude. Yeah, you want me to draw this on Desmos? Yeah, that's actually a really good idea. Let's do it. Yeah, because I don't know if I'm going to be able to... graphing this by hand would suck. Especially when you start doing the stretches and everything. It's kind of a mess. Yeah, let's... Here, let me screenshot this so I can just have it later. Yeah, let's use Desmos. In reality, if I do have a graphing calculator, but Desmos is prettier. Yeah, I mean, you're right. Yeah, I do have this. We could use this to graph it, but Desmos is a little bit faster than the TI-84, even though it is the gold edition, you know. Okay, let's go to Desmos. What? Where's like Desmos? Where's the Desmos graphing? Desmos graph. graph for me. Oh yeah. It's just an easier way to graph. It's just gonna look prettier. So here's what I'm gonna do, because I want to show like what all the shifts are. If I try to do it on my graphing calculator, it doesn't have like colors and things, so it won't look as nice. All right, so remember that the parent function, right, was 1/2 to the x. Yeah, this is online. Yeah. Here, if you want this is all it is. Here's the link for it. Equity, there you go. It's free too, yeah. Okay. So that's our original function, right? That's 1/2 to the x, all right? And then I said the next thing I did was I took this to the x and I ended up dividing it by 4. So here, let's put this all in the parentheses so we can like do things nicely to it. Oh, is it TI-84 online? Oh, no. The actual this is an emulator. Yeah, this one right here. This is an emulator. I had to build this. You have to use like ROMs and stuff. It's a little complicated to do it, and then also I reskinned it. But yeah. Okay, yeah, no, I like that. Yeah, Jeff. Yeah, let's do that. Let's just say f of x is 1/2 to the x. Yeah, let me put this on a separate one. There we go. So you guys can see like what the transformations are. Oh, I like that even better. Yeah, Jeff, I do like that. Okay. All right, cool. Yeah, that's even better. Am I allowed to do that? Can I say f of 1? Will it let me do that? F of x. How do I do that on Desmos? Can I do that? Can I have it reference this equation? Oh, okay, cool. You got a link for it. Thank you. Ah, okay, cool. Okay. So here we go. Yeah. So this is the parent function, f of x. Yeah, thanks, Jeff, for this. Is great. Yeah, this is why Desmos is also cool because you can just like send me a link and we can see it. So yeah, look, when we take the x, we divide by 4, we end up like stretching it, right, in the horizontal direction. Okay, and then what we're gonna do is we're going to move it over. Okay. Actually, here, let's do all the transformations like individually. I think that would be really cool. So this is minus 3/4, right? So look how we've now moved this to the right by 3/4. Okay. And then what did we say we were gonna do? Okay, then we multiplied it by -1/2, right? So -1/2. Okay, so we compressed it and we flipped it. Also, they should make this a different color, dude. What? Can I make this a different color, please? Yeah, change the color. Let me make it orange. Nice. Okay, cool. And then I think the last thing we did was we did it down by 1, right? Okay. There you go. Change the settings. Can I choose any color? No, I can choose purple. Okay. So yeah, so there you go, Equity. Yeah, that's how you do this. That's the series of transformations. So the parent function started at x, and you can actually see if let's redo like what our whole function was. What was it? It was minus 1/2, and then it was 1/2 to the, and then it was x/4 minus 3/4. And then it's -1. Yeah. Okay, cool. Yeah. So look, do you see how this is based? It's the same function is what it is. Yeah. Here, we'll make it red as well. So yeah. So it's the same thing. Yeah, it's pretty cool. Yeah. So here, I'm gonna say, can I save this? Will this here? Let me save a copy. Okay. Will it just do this? Is it collaborative? No. Yeah. You have an account, right? Is that what you have? I forget what my Desmos account is. Okay. Whatever. But yeah, here it is. You can try it for yourself if you want. Oh, you're not logged in? So wait, how do I just share this? Can I just share this? Oh, here we go. Oh, nice. Okay, cool. Yeah, there you go. So there you go. That's the graph if you want to go do it. Yeah. I appreciate that. It's just the share link up there. Yeah. So that's a cool way to show what the graph is. Yeah, you're very welcome, dude. Nice.
was fun.
Nice.
Nice, dude. Yeah, thanks, Jeff, for showing me that. Yeah, it was a good idea to do that on Desmos. Yeah, that's cool. Sensation! What's up, dude?
It's 2 a.m. Kill me now.
Kill me now, dude. So that's kind of late. 2 a.m. is kind of late, yeah, for sure. Did you go to the gym this morning? I went. I did back day. Did back day.
I'm about to go in a minute, yeah.
Nice, dude. What's on the schedule for today? What are we working out?
Full circle.
Full circle? Oh yeah, you do like doing all the weights. You like doing all the muscle groups.
Oh, because I'm fat, I just need to do as much exercise as possible.
Because I'm fat, I just need to do as much exercise as possible. Equity has a quick question here. One sec. What does it say? What is the triangle called if a squared plus b squared is less than c squared? Is it acute? I think this is an acute triangle, right? Yeah, this is acute, right? I think if it's greater than, then it's obtuse. But then you also... It's not fat, I'm obtuse. Yeah, or obtuse also means like dumb, right? It means like daft or something. There's also this requirement though. A plus B must also be greater than C, always. So whenever you're making a triangle, any sum of the two sides always has to be bigger than the third side. Yeah, exactly. Yeah. So there's a stop on this. This has limits. Eventually, you just have a straight line. Yeah. Amog says 10 more minutes. 10 more minutes for what? What's happening in 10 minutes, Amog? What's up? Let me have out Saint. Let me see if Saint's here. 10 more minutes to what? Till we save the world? We gonna save the world, dude?
10 minutes to midnight.
Bro, I played this beautiful track, Sensation, at my event on Friday. It's a Boys Noise track, but he goes like 10 a.m., 9 a.m., and it just, yeah. Wait, if A plus B is greater than C, can't you use square of both sides? You can, actually. Well, okay, yeah, sorry. Yeah, so if A plus B must be greater than C. No. That becomes A squared plus 2AB plus B squared must be greater than C squared. Yeah, Twitch is easier? Okay, cool. Yeah, this is true. Oh, you were joking? See, I was like, Jeff, dude, that's so not you, dude. So if you have a 6, 8, 10, 6 and 8 are the legs, and the sine of 90 degrees would be 10. I put cosine of 90, which gave me 0, but 6 over 10. Wait, what? Why are we doing sine and cosine? Oh, it's because you're on FaceTime? Oh, get off your FaceTime, dude. What? Are you FaceTiming your girl, dude? What's going on? Sine of 90? No, sine is opposite over hypotenuse. Oh, which is, yeah, sorry. The hypotenuse is 10 in that case, yeah. Cosine of 90... adjacent over hypotenuse. Oh. Jeff, yeah, he's asking... dude, I don't think you can do that. Well, because, yeah, here's the problem here, Equity. If you're taking the right triangle, right? And so cosine, right? Yeah, is adjacent over hypotenuse. But, like, which one is the adjacent to this angle? You don't know. Trust me, I would get off FaceTime. She just left my house. We don't need to be on FaceTime. Yeah, girls are always trying to take your time, man.
Okay, G, I'm back.
All right, good to see you, Moog. 10 minutes. Or you were taking 10 minutes to come back. That's what it was.
Yeah.
Yeah. Equity. Yeah, you can't. Equity, you can't do that. You just can't. This is like a no-no. Yeah, just don't do it. It's a cool question, but yeah, don't try to. You don't know what the adjacent or the opposite, like, it doesn't matter if either of them. This is another thing in math. You can't have the possibility of two answers, and it's not a function anymore. Another way to think about it is look at a 90, 89, 1 triangle and see the cosine there. Okay. Yeah, try that on Equity.
Wait, you can have two answers in math, right? Like plus and minus.
Yes, but yeah, it's not really like a function. I mean, there's a reason why, like, for instance, arc sine, arc cosine, everything are only defined in certain quadrants. Is because, like, you can't have two answers.
Oh, yeah.
All right, here, let me help say no.
Wait, hang on, he said 989. Oh, no, that's right.
Hello, what are we doing? Savartadoadoan. We're helping out students with their questions. If you have a question, you can ask one, dude. It's in the Discord. All right, let me do this one. Homework help. Yes, good job, Bob Rosses. Appreciate equity. You telling them? Okay. Identify the holes, vertical asymptotes, x-intercepts, y-intercepts, and the horizontal asymptotes of each. Yeah, they love doing this, dude. This is a classic pre-calc question. It's just like, figure out all this shit, please. And you're just like, what? No. Like, I don't want to. You see number one? Okay, cool. All right. Whenever I see stuff like this, Saint, whenever I could have used this a few years ago. Well, hey, you're here today, dude. There's no such thing as stopping to learn, you know? You may still need it now. Or you may need it later. Yeah, or in Sensation's case, yeah, it never ends, dude. Never ends.
Or in my case, it never began, but never mind.
Yeah. That's okay. Okay, cool. Yeah, hang around, dude. Yeah. Yeah, refresh your knowledge, dude. We're here. Also, like, if you ever want to, like, learn more math, we have a lot of other math streamer friends. There's their, that's all their channels. So, yeah, go give them a follow and stuff. And they also do fun little math streams if you want to just refresh your knowledge on math. I do everything. Math, physics, chemistry, whatever. A lot of math, though. Yeah, you're very welcome, dude. Nice. All right. Anyways, yeah, Saint, you're right. Yeah, let's factor this. How do I factor the top? How do I factor the bottom? What do I get? What are my factors? Can I factor the top? Yes. And I can factor the bottom, I'm pretty sure. Wait, can I? Yes, I can. I can factor both. What do they factor to? We serve no purpose in life. Gold is a W, man. I appreciate it, G-Man. Yeah. Okay. So this top here, yeah, 2 and 4 for the first, right? Yeah. I'm always like, what multiplies to 8 but adds up to 6? Perfect. And yeah, that's 2 and 4. So that's going to be x plus 2, x plus 4. Awesome. What about the bottom? 2 and 3 for the bottom. Yeah, good. All right, cool. X plus 3. Okay, cool. So, right off the bat, whenever I'm trying to find holes, do we have to set it equal to 0? Yeah, good. Yeah, we will. Yeah, so let's go in order. Let's find the holes first, okay? So, holes occur where this function would usually break, like by dividing by 0, but because we're able to factor that thing that breaks it from the top and the bottom, we're able to cancel them out. It creates a hole. This is called a removable discontinuity technically in calculus, but yes. So if I look here at the bottom, right, like x is equal to -2 or -3, that would cause this to be dividing by 0, which is bad. No. Like, you don't want to divide by 0. That creates vertical asymptotes. However, this one already gets canceled out by the top. So this actually technically gets rid of it. So that's why I would say, like, cool, there is a hole at x is equal to -2. And then technically what the teacher can ask you is then what is also the y value. So at that point, you just plug that in here for the y value. So that would be x is equal to -2, y is equal to, if I plug that in, right, -2 plus 4 is 2, and it's 2 over 1, so it's just 2, right? Okay, so that's where the hole is. It's at -2, 2. All right. Vertical asymptotes, that's wherever we divide by 0. So that's just going to be, we're going to say VA at x is equal to -3, because that's what causes this to divide by 0. Okay, Nick, we'll see. X-intercepts. Okay, so there are two things, right? We have x-intercepts and we have y-intercepts, right? X-intercepts is where they hit the x-axis. So this is what we do is we say we set y equal to 0. Y-intercepts is where it intersects the y-axis, and that's setting x equal to 0. If you want to see what that is on a graph, right? If I want an x-intercept, right, that's hitting here. That's when y is equal to 0. That's the x-intercept. If I want to hit the y-axis, right, that's when x is equal to 0, right? Would the x be -4, 0? Let's check, dude. Yeah, sure. Okay. If I plug -4, yes. Yeah, x-intercept is actually pretty easy, because all you have to do is you just have to set the top equal to 0 and make sure it doesn't make the bottom 0. Because, yeah, right? Yeah, if this is just -4, this whole thing goes to 0. And then I don't care what's on the bottom here, as long as it's not 0. So yes, good. So yeah, x intercept at right. Yeah, you said it. -4, 0. They're also going to want coordinates for things, right? And then the y-intercept is easy. You just plug in x is equal to 0. So if I plug 0 into here, that gets me 4 over 3. Okay, so that's going to be like, okay, cool. That's at 0, 4/3. Cool. All right, last step is the horizontal asymptotes, okay? 2 ways to do it. You can either remember the rules about what the powers are on the top and the bottom, or you can do like the limit definition, which is dividing the top and bottom by the highest power of x, and then just taking the limit as x goes to infinity. That's one way to do it. In this case, right, our reduced function is just y is equal to x plus 4 over x plus 3. Since the powers are the same, see it's power to the 1, power to the 1, you just look at what the coefficient is in front. So the coefficient in front is not 0. It's technically 1. Yeah, I could draw the function too. Yeah, and this is equal to 1. Yeah, we'll draw it on Desmos. We'll do it. So this tells me, right, that the horizontal asymptote is at y is equal to 1. Okay? The other way to do this, Saint, if you wanted to, is look at what happens to the function as x gets really big to the left and right, as x goes to positive infinity and negative infinity. And the way I do is I divide everything by the highest power of x. Highest power of x is just x to the first. So this would become something like this. It would be x over x plus 4 over x over x plus 3 over x. X over x is just 1, so this is 1 plus 4 over x over 1 plus 3 over x. And then you say, okay, what happens as x gets very, very big? Because again, horizontal asymptotes, which, you know, kind of look like this, they're like, what does the function approach as x goes to infinity? All right, so once I have this form, I end up just like this is called taking a limit technically, but you can just plug in infinity for x and see what happens, okay? And it turns out any number divided by the biggest number in the world, which is infinity, that just goes to 0. Right? This goes away, and you get the same thing. 1 over 1. You won't have 0 over 0 because you still have a 1 here, and you still have a 1 here. Yeah. Now, yeah, where you're right, yeah. So let's say, however, let's say the powers are different, right? Let's say it was x squared plus 4 over this, right? And then we did this. Let's say we did this. Say we divided everything by the highest power of x in this regard, right? Right. This gets a little messy, right? This becomes 1 over 4 over x squared over 1 over x plus 3 over x squared, right? So this ends up going to 0. This goes to 0. This goes to 0. So you have 1 over 0, right? This is basically infinity, okay? Which means that there are no horizontal asymptotes. Like this just approaches infinity. So yeah, that's the trick of why to do it. If you wanted to graph this, yeah, we could. Let's do that. Desmos, let's learn together. Wait, where's my Desmos graphing? Yeah. If you so here, Savart, if you want to, here, I'm gonna show you my. I do TikTok videos on these topics. So anytime I have like a certain concept that comes up a lot, I'll do like little TikTok videos on things, and I have done one specifically on all the different horizontal asymptotes and how to find them using limits. So here's the link to that if you want. If you want to just like refresh your brain on a bunch of like commonly misunderstood math topics and like watch some funny memes along with it, I have a TikTok where I do everything. Use substitution, factoring, quadratics, simple derivatives implicitly, sig figs, some physics in there, and then like some chemistry too. So yeah. Cool. Yeah, I saw G-Minay. Yeah, I'll process that stuff on Sunday. I process it on Sunday. Okay. What was the graph for this thing? Sorry, what was it? X squared plus 6x plus 8. Okay, so divided by x squared plus 5x plus 6. Cool. Yeah, so this is the graph. Yeah. Oh, you don't really have TikTok? It's okay. If you don't have TikTok, do you have YouTube? I do them on YouTube as well. So, yeah, if you have YouTube, here you go. There's my YouTube. I post them all. The problem with YouTube is YouTube only allows my shorts to be a minute long, which is annoying. So you have to kind of do them in parts. There's like a part 2, part 3, part 4. But they're all there. Just start at like part 1 and keep going. TikTok allows me to do up to 5 minutes, which is a lot easier. But yeah, we have all of them here as well. Yeah. I agree, TikTok is cancer, but it's the way the kids like to interact, so that's how I reach them. I always wish I was like you. I'm addicted. Yeah, well, they make it hard, dude. They do. Okay, cool. So yeah, here's the graph. So again, let's look at like some here. Let me pull this thing in. Give me a second. There we go. This. Yep. Okay. No, that is not what I wanted. Okay. So we can kind of look at this graph and kind of see if it has the same features, right? So vertical asymptote, right, at x is equal to -3. That pops up right here. That's what this is. This is the vertical asymptote at x equals -3. Here is the x-intercept, right, at -4,0. Is right here, right? Here's the y-intercept at 0,4. And then here is also the horizontal asymptote at y is equal to 1. Oh, let me move that around, sorry. So there you go. That's the y is equal to 1 horizontal asymptote. And then you can't see the hole. The hole doesn't show up. But because it's you'd have to go like really, really far in to go find it. Yeah. Okay. Cool. Yeah. Good question. Good question there, Saint. Thanks, dude. Say 2000. Nice. Okay. What's up, Emogi? What you had a quick whatever question? You're feeling dumb or something? What's up?
Yeah, so my dumbass solved 16. Now all I need is 15.
Okay. Where did you send it? You sent it in the chat?
Yeah.
I'll do it just because it's quick.
Alfredo. Peppo and Alfredo. I went above that.
The one above that. This one? Man, dude, what?
Sure.
Why is this like the smallest image known to man, dude? What? How did you screenshot this, dog? It's okay. It's okay. I got it. Pepe and Alfredo, dude. What? Is Pepe real, dude? It's not just a
I
meme?
don't even know. My physics teacher, like, is on crack half the time.
Okay. Pepe and Alfredo are resting on an offshore raft or swim. They estimate 3 meters separates a trough and adjacent crest. Okay. They count 16 crests that pass by the raft in 21.5 seconds. Calculate how fast the waves are moving. Okay. A trough and an adjacent crest. Dude, what? Excuse me? Why are they using these weird words? You just say a min and a max, dog? Like, what? Why do they use trough and crest? I don't know. What's this? Oh, so this is a trough. This is a crest. Is that what that is?
Yeah. Yeah.
Okay, cool. Okay. So this is 3 meters. So right away, what's the wavelength?
6.
6, yeah. Do I know circuit analysis? I do. You talk about like Theneven stuff, Theneven or whatever. Yeah, I can do that. Like Kirchhoff, loop laws, mesh analysis. Yeah, I've done that. Yeah, I have. I'm not the best at it, but yeah, I have taught it before. Yeah. Okay. 16 crests. All right, so this is a crest, right?
Yeah.
That passed by in 21.5 seconds. Okay, so that should tell you the period, right? Because the period. So well, it actually tells you the frequency, right? So frequency is number of oscillations in a certain amount of time. Okay, if you have 16 crests, that's 16 oscillations, right? Because there's only one crest per oscillation.
Yeah.
Right. So it's 16 over 21.5. So that's the frequency. So frequency is equal to 16 over 21.5. Lambda is equal to 6. Don't you just multiply the two together? Or you divide one of them? What is speed? What is wave speed again?
It's 4.5.
Is it?
A total answer if you multiply, you get 4.465.
Sorry, isn't wave speed lambda f? Isn't that it? Is that what it is? I forget.
Let me check the notes.
Yeah, it's F lambda. Okay, cool. All right. So, wait, stop.
I can try it.
No, give me a second. Let me just make sure it's right. So 6 times 16 divided by 2.5. Yeah, it should be 38.4. Or 21.5. My bad. Wait. Yeah, 21.5. Sorry, my bad. I'm putting things wrong to the calculator today. 21.5. Yeah, 4.47. 4.4. Yeah, not 4.45. How many? I see 3 sig figs, so it should be.
Yeah, but the lowest is 2, and since you're multiplying and dividing, isn't it lowest on 6 figs?
Yeah, but 16 is like a whole number of crests.
I have attempts. I can do both.
Yeah, so I don't think it, because you're not going to measure like 16.2 crests. It's a whole number, and when that happens, it screws up sig figs. I think it's 4.47.
Okay, I'll try it.
Yeah, try it out. Savart says, I'm tempted to use equations I learned in E&M. Yes, but they don't work. Well, I mean, they do. They do, but...
That's wrong.
It says wrong, dude? Dude, fuck that guy, dude. What?
Does the last part to do anything with it? Assume the count begins at the
No.
end of the crest.
16 crests that pass by. Oh, okay, maybe... So if I counted 1 crest that went by... yeah, I don't know. Is this 17 instead of 16? Is it like off by 1?
I don't know. Can you like draw it out real quick?
Well, no. What they're saying is that, like, you know, so I let's say for instance I count 1 crest. Okay, if I count 1 crest that passes by, am I counting this one? That's assume the count begins and ends at the top of a crest. Like, okay, if I'm from here to here, am I counting that as 2 crests or 1?
I would say 2, but
I would say 1 because technically only 1 crest is passed. But yeah, you're right. If so, then this should be 17 over 21.5. Dude, I hate when like it's just like the English like messes it up. Okay, try 4.74.
yeah, no, wrong.
Okay, well,
I can try 4.7.
one sec, dude. What?
Yeah, I have 2 more attempts left.
Yeah, what? No, this should be fine. I have this right. Yeah, crest. They estimate that 3 meters separates a trough and an adjacent crest. Wavelength is 6 then, dude. And then it's 16 oscillations. Yeah, in 21.5. I think they're wrong. I think the question's broken. Yeah.
Okay,
No,
I'll just use up all my attempts and ask my teacher.
Yeah, just ask your teacher. Tell him he's wrong. It's okay. There's always bugs in the stuff. Savard says, yeah, attempted to use E&M. Yes, you can use, again, Kirchhoff, loop laws, and junction laws for circuit analysis. However, stuff starts getting so complicated that you need to use these new engineering techniques, which is mesh analysis, node analysis, Thevenin circuits. Like, these things are nice algebraic tricks that, yes, you could manually solve with just E&M physics, but it would take a long time to do it that way. Oh, you're an electrical engineer? Cool. Yeah, so you get it. I'm a PhD plasma physicist, so like, you know, we're brothers of the same cloth, right? A lot of plasma guys are EEs as well, but yeah, EE tends to use a lot of you know, shortcuts, which I'm more of a fundamental, like, just get me KVL, just get me whatever, it'll work. Yeah. Okay, let's see. We did Saint, we did Taco Cat. Ethan, you are next. What's up, Ethan? Let's do it. Oh, and then Gawked is here, and then Dark, and then G-Man. Okay, cool. Which one do you want to do? Can we?
Which one do you want to do?
Yeah, what's up?
Yeah, what's up? You remember what you gave me?
Remember the what I gave you? What I gave you, sorry?
The green controller? The green Xbox controller?
Yes, I remember the controller I gave you. What's up?
Apparently it was so dirty that it just came, that the plastic came off. Like, Now I'm seeing what's on the inside of the controller. The stick.
Yeah, you need new thumb caps. Ethan is what you need. You just need new thumb caps for your controller.
Now I feel like my dad's going to kill me if he sees this.
Why? No, it's okay. You just use the controller. Like there's wear and tear on items. That's natural. It's okay. It's just a shame you live in Belize. It's so hard to mail things to Belize.
Honestly, like I gotta live a sad life. That's it.
No, it's okay. Don't live a sad life. We'll figure it out. There's got to be a video game store next to you somewhere in Belize, right? I think so.
No, there is no video game store.
Bro, I can't believe there's no video game store in Belize. Like
No. I mean, like not near where I live.
okay, but there's got to be something
I feel like
in the
there are
country.
video
There's got to be
games.
something. There's got to be something in the country or in the city. Yeah. Here, let's do your physics question to see what you got wrong. The challenge question you put is cool, but let me do this one just to make sure. Svart says it's just that I graduated a while ago. Now I work as a developer. Okay, cool. So you forgot a lot of physics, math. Yeah, you forget it, but it comes back, man. Always comes back. Never truly leaves you.
All right.
That's what I say. Okay, let's see. What was wrong?
Because, you know, I'm
Oh, we went over this, Ethan. I told you what you did wrong here on this question.
Yeah, I know, but it's like I want to see the last two because it's like I do not know if I got them correct on what I did.
What do you mean? Oh, because I told you to do the last two, right? Is that what I said?
Yeah, like E to F and F to G. That's it.
Okay. Man, I deleted all these pages because I already did this for you at one point, but I don't want to have to redo all of it again.
I mean, I can, like that. I have the answers with me.
Yeah. Okay. Well, I mean, sorry. E to F and F to G. Do you have the other numbers that we did earlier? The last time I worked through this with you, dude.
Yeah, we did. Yeah.
Did I send it to you as a screenshot? Did I send it to you?
No, I just reviewed back on the stream.
Oh, okay. What are the numbers? What are the numbers for like what did we get here for like A, B, and then well C and D is okay.
Hold on. Okay, yeah. So from O to A, from an XC graph, the number was 960.
Good, thank you. Yeah, that's all I need. Okay, 960, and then what was A to B? What was the one up at B?
2,640.
2640. Okay, cool. And then it's C.
3,360. But you said a different number.
Oh, did I? Okay, well let's make sure I'm right there. Let's make sure I'm right there. It's okay. All right. So again,
look at O to A and A to B.
Yeah, that's okay. So whatever the area is underneath a velocity graph, that's the amount of distance that changes from different points. Is what it is. Yeah. Moog says, "What's the best way to memorize the entire of Latin America with a few capitals?" I don't know. There's probably a song. There's probably some song, dude. It's like Quito, Ecuador, Lima, Peru, La Paz,
No, like
Bolivia.
location.
What do you mean the location? Oh, like where they are?
Like, which countries which? Yeah.
Oh, I don't know. Flashcards. I don't know. Memorizing is for robot
How's
dog.
flashcards supposed to help me?
I don't know. Just like have a flashcard. Be like, which one is this, and like color it or something, and then be like, oh, that one's Colombia.
Okay.
Okay. I don't know.
All right, I'm gonna go then. See
Yeah,
you,
go
bro.
for it. All right, you're good, dude. Good to see you. All right. Fuck, this is blurry, dog. What are the points at B and what are the points at C here? Can I get the
Sorry,
points? What's the point here?
yeah.
What's the point?
Point at B, it's 150 and 24, X1 and Y1, as you would say.
Okay. What's the point at C?
2,
Oh, okay.
and 0.
I got you, Cuber. I'll still be here. 2:10. Yeah, go eat some dinner, dude. I'll still be here. How long are we streaming? Oh, only hour 49? Yeah, I'll still be here. This is 2:10 and 0. And then
Yes,
what's at D? Just give me all the numbers real quick while we're here.
230, 0.
Okay. This is 2:30 0.
You forgot about A. It's 80 to 24 as well. For
Oh,
A.
I don't need those because you already told me that these are okay, right? These numbers are correct.
That I have no idea. I mean, like, I'm sure OTA is correct because we both got the same number.
Yes. And did we get the same number for B?
Mm,
The 2640?
remember, yes.
Okay, then that's fine. We're good.
Yeah, but then C to D.
That's okay. Yeah, that's why I only need the numbers for B onwards. So B, C, D. What is it for E?
E is 290 negative 30.
Okay, so this is 290 negative 30. Okay. What about this one?
340 negative 30.
Okay. And then this one I know is 0. Is this 400 0?
Yes, yes.
Nice, okay. All right. Okay, so the area underneath a velocity versus time graph, see, this is velocity versus time, gives me the change in the displacement. Yeah, VT gives me the change in the position. That's called the displacement. So, right, from B to C, we're trying to get what the numbers are. So I got to look what happens on the area of the velocity versus time graph for B to C.
Basically, we have to like find the area of a triangle, which is half times space times side.
Good, very
and then
good.
We get that number and add it to 2,640.
Okay, cool. So what's the area of this triangle here, Ethan?
Wait, hold on. What is the base and the height?
Well, it goes from 150 to 210, so that tells me the base is 60, right?
And the height is 24, right?
Yes, height is 24. Good. Cool.
Oh, hold on. Let me get. I got the calculator. Hold on.
All right, you want the calculator? Yeah, do it. I can do it too.
60 and 24, right?
Mm-hmm.
Okay, I get 720. Yes.
Good. Yes. 720. Nice. So, and that's positive area. Do you see how that area is above the whatever axis, above the x-axis? So that's going to add to our position. So we're going to add 720 to whatever this is, which should be 3360. Yeah.
Yes, you're correct.
So up here we should be at 3360. Okay, cool. And then from C to D is just there's no area. So this stays the same.
Yeah, it's stationary. But Tatico,
What's up?
I think you said 3660 last time.
Oh, I was probably I was
me to see.
dyslexic or something. It's okay. Happens.
I think you were tired.
I was definitely tired. Yeah. Okay, so what is the so right, there's no area from C to D because that's a straight line at 0. What happens from D to E?
It starts to actually decrease.
Mm-hmm. How much does it decrease by?
Can I see the height and the base of the triangle?
Yeah, so D is at 230 0, and then E is at 290 negative 30.
So that's like 60 for the base.
Uh-huh.
And negative 30 for the... Wait, isn't 30 just positive then, for some reason?
No. Well, yeah, make it positive, and then we'll make the area negative. It's okay.
Okay, well, I got 900, if you're correct.
Yeah, good. Yeah,
Yeah,
half times 60 times 30 is 900, right? Negative 900, okay? Right, so let's make that like a blue area, okay?
So then what we do is that we subtract it from the previous number,
Right.
3,660.
Right, it subtracts, yeah. So, 900 minus this is going to be 2460. Right? And this is where, like, you had the curvature wrong,
Yeah, I get
right?
that.
So, this is
Yeah,
this
I
is
know.
going... Good, okay. The velocity is going down, and it's getting more negative. So it has to be this way. It has to be this way. Concave down is what we call that. Okay.
Alright then.
What about from
And
E to
then
F?
E to F. Hold on. The area of a rectangle.
Uh-huh. What is that?
Is it 1,500?
Mm-hmm. Yeah, good. Yeah, it's 50 across, 30 down. Right, 1,500. But it's negative, right?
Yeah, so that should go back to 960, right?
Good, 960. Cool. Well, yeah, it's good. It should be the same line. And then, what about the last part?
G. Hold on. That's 340, right?
Mm-hmm.
Hold on. I get 900 as well.
Good. Right, yeah. Because right, it's a distance of 60, 30 down, 1800 divided by 2, 900. It's minus 900. So right, this shouldn't go to 0, right? What is this going to go down to?
No, apparently not.
No, where's it
It's
going to
gonna
go?
go down to 60.
Good, 60. Nice. Good job, dude.
Alright, that's all I need help with. Everything else is okay then. That's about everything else is
Yeah,
okay,
good.
alright?
Nice job.
Very nice.
Let's see Paul Allen's card.
Let's see Paul Allen's card.
Love
Alright
that
then.
movie.
Well, also Dr. Go, I wanna tell you some stuff.
What's up? What do you want to tell me, dude?
I'm going to get a quiz on physics the first day I come back.
Okay. Do you know what's over?
It's it's based on different topics, but we actually went over one of these stuff.
What was it over?
Well, it deals with kinetic and potential energy.
That's good stuff. Yeah, kinetic energy, potential energy. All very good stuff.
And they also talk about like some types of energy and like work, energy, and power.
Yeah, those are all very good concepts. Let me see if Gawked is here. Gawked has a cool question. This is kind of like,
So, I wanna
yeah?
ask you,
what do you want to ask?
do you know what's a solar oven?
A solar what?
A solar oven.
Yeah, a solar oven. Yeah, it's a way of cooking things with the sun.
It's like I am doing this for like my exam grade, and I'm supposed to construct like a blueprint of it. Like,
Yeah, probably just like draw a
what each
diagram or
parts I'm
something.
going to do.
This is cool.
Yeah,
this
I
is all solar oven. Yeah, basically what you're doing is you're taking all the sun rays and you're focusing them on a single thing. That's what a solar oven is.
Can you help me with that, please? Like for a bit, like off stream.
Yeah,
Because
yeah.
like it's worth half my exam grade. Well, it's worth for my exam grade, and I need to do it and submit it by Monday, next week Monday.
Mhm.
Like if only I could just message you, then you can definitely help me.
Yeah, I can. Yeah, just send me DMs. Or like we can do it on the stream. It's okay. We'll figure it out.
Okay.
Cool.
Okay.
Where is Nick? Nick, where you at, Nick? Come back here, Dark Aspect. Where you at, Nick? Where'd you go, dog?
So,
Yeah, good questions,
to do-
Ethan. What's up?
Mhm,
With
go-
G-Minute.
Two other things. Like one question I want to ask is that what are you gonna do for the weekend? What games are you playing on the weekend? Like I know Jackbox is one of them.
Probably Roblox, probably Jackbox, probably, I don't know.
What did you
probably
wanna
do Fortnite.
Like, goes up to-
We can probably do the new Doors at some point. Let me give a break for it because people were kind of mad at Doors last time.
Yeah. But yes, you were saying about Gawk's question, it looks like some potential and kinetic energy
Yes,
as
so
well.
yeah. When Gawked gets here, we'll do their question, but this has to do with you see how like kinetic energy and thermal energy is like the energy lost to the friction, and then there's gonna be like some compression stuff. It's all good stuff.
Wow. You wanna know? You wanna know the definition of thermal energy?
What is it? What's the definition of thermal energy?
The energy due to the motion of particles of a body.
Oh, that's cool.
That's what
Makes
they
sense.
have it as.
I like that. That's good.
All
right.
I'll stick around to see the docs here.
Yeah, stick around, stick around. Yeah, we're gonna try to do this one. What I guess Nick just Googled like hardest easy math problem. Like what? Is this the hardest
Yeah, I
easy
guess
math
so.
problem? Okay. Nick says I'm here, but I can't talk. Okay, you at least gonna chat, dog. All right, we're gonna try to find X. That's cool. And you can redeem some coins. What's up? Okay, great. Okay, Nick, how do I find X? How do I find X? You see how this is like a triangle and stuff, man? So, triangles are cool. Would probably be cool to find some of the angles around it. What's the easiest angle Here, I'm just gonna label all of them. I'm gonna say 1, 2, 3, 4, 5, 6, 7, 8. So you tell me which angle you think is easy to find. What's an easy one to find right away? And let me label some more. Here's like 9. Here's like 10. 1. Cool. Yeah. What's angle 1? Let's do it. $150. Yeah. 180 minus 50 minus 60. Yeah. Good. Yeah. This whole thing has to add up to 180. So this is 110. So that means this is going to be 70. Okay. If I know that one's 70, what's another one I know? This is actually cool. It helps you solve a bunch of other ones, right? Yeah, angle 3, good. What is angle 3 going to be? 70.
Perfect.
Yeah. Yeah, these are called vertical angles, is what they are, when they're across from each other. Okay. Do you know what angle 2 is then? Uh-huh, yeah, what's angle 2? That was a good one. 180 might... Good, exactly, yeah. So this makes a line, which is 180. This also makes a line, which is 180. Right, so this is going to become 110, which then means that this is 110, right? It's kind of cool. Where do we go next? Where do we go next? We can find 5 and 9. Right, yeah. 5, you know, right? Because here's another triangle, right? That's pretty easy. So that's 140, so that means this is going to be 40. This is 130, which means this is going to be 50. Getting closer. Okay. I think you're done actually at this. Oh, no. We don't know what this. Sorry, 10 is the angle. We don't know what this one is yet. We don't know. We'll call this one question mark. What's another one we can figure out? I should have done different colors. That's what I should have done. 8. Okay, cool. What's 8? $180 minus 60 minus 50. Okay, not quite. Yeah, no. Yeah, good, right? Because you see how this is the big triangle? It's this. This is the big triangle. Oh, did you? I don't remember it. Good. Yeah, so this one's 80. This one's 80, right? So that tells you this is how much? 20. Was this one hard, not your friend? I don't know. I do so many questions. We were stuck on this for an hour and a half? Oh, I hope not. Oh, no way, dude. Is it going to be that bad? I hope it's not. Really? Oh, fuck. Fuck. Okay. I feel like we're almost done here. If I have to do some, like, crazy voodoo math, I will, but I feel like I can brute force this with algebra. Let's just call this one Y. Okay. Okay, yeah, and we don't know 7, and we don't know 6. Yeah. Goldie, have you ever thought about teaching in a school? I have, but I don't think I'd last very long there. I'd probably get fired for, like, saying something wrong. Also, you know, it's more cool. I can teach more of you guys than I can. School I can only teach like 30 kids, you know. TikTok I can teach millions. You know, here we can teach as many people get on the stream, which sometimes is like 150. So yeah, maybe at some point I'll give in and just go teach at a school. But again, I don't really do well with like business stuff like that. Not business stuff, like, you know, formal stuff. Yeah, I only do tutoring. Yeah, that's what I do to pay my bills, which is getting harder and harder these days. Okay, Nick, it's all right. You're like, yeah, we're kind of lost here. Let's see what happens. Okay, so I think I want to use kind of like a systems of equations here, right? Okay, so I know that this is a triangle, right? Where this angle and this angle and this angle all have to add up to 180. Okay, so let's just make this as a system of equations, and I think this will pop out nice. Okay. So I have 30 plus y plus x plus 40 must equal to 180. Right? That's just from this triangle. Okay? Okay. And then I also know this, right? This is also a triangle. I also know that x... Oh, dude. Dude, yes. Okay, now I see why this one, like, messed me up, dude. Yeah, x plus y plus 70 is equal to 180. Oh, man, dude. It's the same fucking equation. Oh, shit. Uh-oh. No. Oh, you're about to hurt me, dude. Yes. Yeah, because then this is... Okay, because then what I also try to say is this is a quadrilateral, right? So I say that 40 plus x plus 50 plus y plus 80 plus 80 is equal to 360. So that's... that makes it 200, 160. Oh, maybe not so bad. No, also bad. Okay. That doesn't do anything either. It's the same equation. Oh, man. Yeah, not your friend. What was the trick here? Man, we're close. I'm always like, damn it, we're close. They, like, draw something, I remember. They draw, like, a weird triangle or something. Because then this is like, another triangle we have. We have this, right? So, this is just, again, yeah. X plus Y plus 70 is equal to 180. Noise did it in office hours? Where did you do it? Is this one of those stupid ones you have to start drawing extra triangles? Yes. Yes. Yeah. Yeah, you know, I see it. He didn't do it. He tried to do it, but yeah, it's tricky. That's a tricky one. Nick. What? Yeah, what's the last part for this? I think they do end up like drawing another triangle. It's really rude of them. You know what? I'm just gonna fucking figure this out. We will find it. Yay, there we go. Yeah, this is rude, dude. They start drawing more triangles. Oh, no. Yeah, okay, whatever. Yo, thanks for the follow, Nostradamus. Yeah, dude. Okay, I don't want to do this one, but cool. What the hell? How did you do that? Yeah, whatever. It's yeah. Here we go. At noise, unfortunately. No, because I've done this one before. Yeah, you're right. I have done this one before, and I just don't want to do it. Okay, cool. Whatever. That counts a question. Yeah, I just don't want to do it. I'm just tired. There's a solution if you really want it, but you know, it's fucking ugly, dude. 30 bond coins, nice, dude. Did I give you weekly question yet this week? No, I didn't. Okay. What was it? Give coins at dark aspect 2, 1, 2, 3. Nice. Okay, cool. Let's see. Okay, so that's weekly for you. All right. Let's see. Did you solve it? No, I'm not going to. But yes, if you want the solution, it's right here. It's just a bunch of equilateral triangles. That's what it is. There it is. There's the answer if you want it. Yeah, dude, like what? Like, bro, like you want me to start like drawing all this stuff? Like, it's just annoying. I'm not gonna learn anything from this. But yeah, the trick is to make a bunch of isosceles triangles. But yeah. Or I guess someone does a YouTube video
Hey,
on
this
it?
is Fresh Talk.
It's cool. Like, bro, if he has to make an 8-minute YouTube video on like what to do here, like I just don't want to do it. But yes. Another cool video there if you want to learn it. Yeah, it's okay. Okay, where's G Monet? Is G Monet gone? 8 minutes. Yeah, 8 minutes. Yeah, I'm just not gonna do it. Yeah, it's just like no fun. Okay, if G Monet is not here, and I'll do Cuber's question first next time, or maybe I'll do a bonus stream on Thursday. We'll see.
Please do a bonus stream since you did not make up on Monday.
Yeah, let me see. Let me see what time I get back from the hairstylist tomorrow.
And
Gotta get my haircut.
What
What's up?
else? Right, did you do Gawk's question as yet?
I asked, but Gawked is not here. Where is Gawked? Where's
Dang
Gawked?
it.
It's okay.
Well, if he isn't here, I can sub for him since I'm still here learning energies.
Okay, cool. We'll do yours. Yeah, let's do it. Let's do it. Whatever. Oh, yeah. This will be the last question.
It's not technically not, man.
Let's do it. It's okay. We'll do it. Last question. Last question of the day. Okay. All right. 3.5 kilogram block is accelerated from rest by a compressed spring of a spring constant 640 Newton meters. The block leaves the spring at the relaxed length and then travels. Okay. Over a horizontal coefficient of this. The frictional force stops the block a distance of this. What are the increases in thermal energy of the block floor system? Okay. That's cool. So.
All right. Well, is this a stretch or compressed spring? What kind
So
of spring is that?
it's compressed. And then it eventually. So it's.
What kind of stretch?
Well, no, it's compressed and then. Yeah, and then it hits like a rough patch is what happens.
Okay. All right.
Relaxed length. Yeah, so the relaxed length is here is what we're saying. So like the spring is normally out this far, Ethan, but it's being compressed inwards this amount, okay? Okay, so
All right.
thermal energy is equal to the work done by friction, which is the force of friction times the distance. Okay?
Wait, what? The work times the distance?
Mm-hmm. Work is
Wait,
the work.
Isn't the spring...
Work is equal to the force times the distance. That's what we learn.
Oh wait, doesn't displacement also work?
Well, yeah, displacement is distance. Same thing. Yeah. In this case, it is.
Okay, well, there's also in my notes here I see that work and energy have the exact same formula.
Yes.
And E is equal to F times S.
Yeah, S. Displacement is also... Yeah, in this case, we're just going to use D. But the key thing here is that the force of friction is equal to mu K Fn. Okay?
To what? To what again?
It's the coefficient of friction times the normal force, okay? Where...
Is it... You call it mu A?
Yeah, mu K. Mu K.
Mu K. Mu K.
So, if this is our block, right, we have the force of gravity pointing down, which is mg, and then we have the normal force, which will also equal mg. Use a little finer.
Does they both have to be equal?
Well, because the block is not moving anywhere. Okay.
I'm gonna ask one thing.
What do you want to ask, dog?
Imagine as if both gravities. Imagine as if one of the gravities was like 9.81, for the normal force, and the FG was like 9.82. Then would there be too much of would Would it
Yeah,
still
and,
be the same? Or
no, it wouldn't work because in that case the block would like fall through the ground.
But then, like, isn't
You'd
it-
have
isn't
to have
someone
another force. You'd have to have another force Ethan pulling up in order for it to balance.
So
You'd
were
have to have-
you mean to tell me that even 0.1 missing will
Yes.
still make it go in
Screwed up, dude.
in one direction?
Well. Yep. Physics be physics,
Okay,
dog.
then. This is physics is weird. Physics is physics.
The real world is a weird place, man, dude. Yeah. Okay, so this is what's up? What's up?
And I thought 0.1 wouldn't make too much of a difference.
It
Turns
does.
out it will, but slowly but surely, right?
Yeah. Here we can use 9.81 for here. Okay. Okay. So this, right? This is going to be the force of friction. It's mu k, which is the 0.25, times the normal force, which is just mg, which is m times g, right? So that gets us the force of friction, and then the distance. Let's remember that's equal to 7.8. So now we can solve for this. Okay. So now we get
You multiply all of that?
ultimately all that together. So this is going to be equal to, let's get our calculator out.
Hey, Dr. Go, hold on. I think I get the answer.
You got it? Okay. What do you got?
Well, just to make sure, I get like 66.95325, something like that.
Okay.
Look yours. I do not think that's correct.
I get 66.95, yeah.
Oh, I get the same thing then.
Nice.
We're both correct.
Good. So this is going to be sorry. This is going to be 66.95, and then the units for this are joules. Yeah, energy is joules. Energy is joules.
Okay.
Yes.
Oh, energy is.
Mhm.
And what about watt then? Like WATT?
That's change in energy over change in time. It's power.
Change in energy over change in time. Well, what?
Yeah, it's another thing. Yeah, it's work over
I
time.
don't know.
It's okay.
Well, what's like the what's like the thing for it? Like how 1 joule is energy? What is watt? Work?
No, watts is power.
Oh, power.
Yeah,
Okay.
it's power. Yeah.
Alright.
Okay, here we go. It's the maximum kinetic energy of the block. All right, so this is actually kind of interesting because
Kinetic energy so to first and foremost point out, kinetic energy focuses on speed rate. It's the body of mass.
yeah, so I think
Right.
so the max kinetic energy is equal to when there's the minimum spring potential energy.
What?
Yeah. Minimum spring potential and also minimum friction.
I do not get that. What?
It's okay. Okay, so we got to figure that out. Okay, cool. So we have to figure out how much, so we have to know how much it was compressed. Yeah, see, this is interesting. I think you have to figure out part C first before you can figure out part B. Or no. Okay, no. I got this. This is kind of cool. So this is when okay, so this is this is cool. This is when, and also it's equal. It's okay. Oh, Cuber's back. Okay, all right, Cuber. We'll do yours next. Cuber, is that cool? Okay.
That would be the last question of the day.
So max KE must also equal at this point the thermal energy lost, which is also going to be equal to 66.95 joules. Okay, because when this thing stops, okay, it's lost all its kinetic, it's lost all its potential, and so all the energy went into friction. That must have been the same as the maximum kinetic energy here, right before it started losing it due to friction.
Okay. I didn't even understand that.
It's okay. It's okay. It's okay. Let me just move through this because I gotta do cubers and I'm tired. Okay.
That's
All right.
I can help. I know Pythagoras is here as well now.
Yeah, you can help with that one too. Okay. So original compression. That's when KE equals 0, and I'm gonna say like work done to friction is also equal to 0. But same total energy. So we're gonna say that one half kx squared has to equal 66.95. Okay. K they give us. K is 640. Okay, so 1/2 times 640. X squared is equal to 66.95. So X is equal to, let's just do it math-wise. I got it. It's just, what is it?
Yeah, you just gotta move the numbers, right?
Just gotta move the numbers at that point. So it's whatever. It's this number.
So it's like you gotta do like 0.5 on both sides, right?
Or I can do the 1/2 times the 640. Ethan is already just 320.
Alright,
And then divide both sides by 320 and then square root it. Because it's x squared. So that gets me 0.457 meters. Nice.
Wait, what? 4.57 meters. What?
0.457. Cool.
How did you get that? I didn't even know how to do it. Like.
Nice. Yeah, this is a good one. Nice. Good.
Okay, whatever.
It's alright, it's alright. I'll explain this one to you in more depth next time, Ethan. We've been almost streaming 2.5 hours, so I just want to get through this. What was this for? This was gawked. There we go, there's gawked. Alright, Cuber, what's up? You want to learn the Pythagorean theorem? Cool, man.
I mean, I could also help.
Yeah, you can. Let's show Cuber what the Pythagorean theorem. What's up, Will Smith? Good to see you, bro. Okay. Okay. All right, Cuber. Pythagorean theorem only applies to a certain type of triangle. What type of triangle is it? What is it? What do we know? What type of triangle?
Participate as well.
Yeah, you can. You tell me. What is it? What type of triangle?
Right angle triangles.
That's dope.
But not all the time it will work. Like, imagine if you had an isosceles triangle and you didn't know one of the sides.
Well, no, it would. It would.
Well, what about sine and cosine rule? What about?
Well, it's okay. Yeah. So here, you just need a right triangle, all right? And then what the Pythagorean theorem says is that if this is A, this is B, the hypotenuse, the longest side, is always C. That A squared plus B squared is equal to C squared. Cuber, do you get that so far? Makes sense.
So basically, the objective of this theorem is to find the missing side as always.
It is. It is. Yeah, I can make you Smeeker. Smeeker. There you go. Cuber, you can come up. Speaker. What's up, Cubes?
Hello.
What's up, dog? What'd you have for dinner, dude? You're making me hungry, dude. I want to go eat something now.
Add some salmon and some grass.
I like salmon. Salmon's great. Big fan of salmon. Fish. Okay. Yeah, so again, this is for like right triangles, Cuber, right? Basically just says that if you square two of the other sides and add them together, that has to equal the third side squared. Okay.
Yeah. So basically, what you do next is like you substitute in values, right?
Yeah. So yeah, Cuber, what do I do next if I was trying to solve this?
I think you like square 16, right?
Good. Yeah. So 16 squared is where in the equation here though? Where does that get squared?
C2.
Yeah. C squared. Yeah. Okay. So this is 16 squared. Okay, that's where this came from. What about all this other shit? Where does that come from?
Good
to see you, not your friend.
A2 and the B2.
Mm-hmm. A squared, B squared. Yeah, don't say A2, B2. You want to say A squared, B squared.
Yeah.
Yeah. Okay. All right. So what are we gonna write there, dog?
12 squared.
Okay. Yeah, 12 squared. That's cool.
Yeah, 12 squared.
Mm-hmm. And what else?
A squared.
A squared. Okay. Do you know how to solve this next? Do you know what to do?
No.
I could help.
Okay. Ethan, help him out. What would you do here?
Well, basically, you would want to simplify it more so that there you just see numbers. So
Mhm.
you're gonna do the squares of each number, which the square of 12 is just 144.
Good.
And the square of 16 is 256. Another way of saying it is like just multiplying both numbers by themselves.
Yeah, exactly, Ethan. That's really good. Did you get that, Cuber? Does that make sense?
Yeah.
Yeah. So yeah, this
like-
one is squared, as Ethan said. It's just 144. This one's 256, and then this thing's still a squared.
So we could like.
Yeah, what do you think we could do, Q?
Minus 144.
Yes, dude. Yes, bro. Yes. Yeah, let's minus 144, dude. Let's do it.
Nice.
What does that get me?
That gives you 112.
112, yeah.
Okay. Last step, cubes. What do I do? You notice I got this like 2 on this thing? This thing looks bad, right? No. We don't like it.
Yeah.
How we get rid of it?
You know what to do? You want to know the opposite of squares?
Ooh, yeah. What's the opposite of squaring? Yeah. That's good. That's a good one.
You gotta square root them.
Yes.
And cancel them out.
Yes. Cuber, do you understand like how to get? Yeah. All right. Sorry, Cuber.
Oh. Well.
So
Wait,
this
what's
is
the square root of 12 then?
the square root of 112.
Yeah, 112.
I don't think we know that. I don't think we know
No, well,
that.
it's not a whole number. I have the answer right here.
Okay. Yeah, we can square root this.
It's-
So squaring a square root gets rid of this. And now you just have a is equal to the square root of 112, which, yeah, as Ethan's right, yeah, we don't know what the square root of 112 is. That's not anything nice, right? So you have to use a calculator for this.
Yeah, which is just 10.583.
10.58. Okay, that sounds pretty cool. The other way to kind of do this is you could break this up. Have you done this before, Cuber? Have you broken up like big radicals like this?
Yeah.
Yeah, right.
Like a number bond?
Yeah, yeah, okay, cool. So do you see how I broke this 112 up and whatnot? Yeah.
Yeah.
Okay, so here's a good question for Cuber. What would this simplify to? This square root of 112. If I want to like simplify this radical, what would it be? Do you remember the rule about like the pairs and like what stays in the house, what gets out of the house?
No.
Okay. So I took this 112 and I split it into factors, right? See, 2 and 56, right? 2 times 56 get me 112. Does that make sense, cubes?
Yeah.
Okay. And then how else can I split 56?
The 2 and 28.
Good. And then how do I split the 28?
2, 14.
Good. And then the 14?
2, 7.
Good. Okay. The next thing you do, okay, once you've broken this all, see, I can't break 7 up anymore. Like 1 and 7, that doesn't count. It has to break up into 2 numbers that aren't 1 and 7.
But you don't realize that you can do like 2 and 3.5. You could do that. And
No, you can't do that. No, you can't do it.
Why
No.
not?
Has to be whole numbers.
Wow.
Yeah.
Okay, then.
Okay, next step you do here, dog, is like you start seeing where you have pairs of things. Okay, do you see how I have like a pair of 2s and a pair of 2s here?
Yeah.
Okay, and then there's a 7 left, all right? Anything that is a pair is going to come out as a single number, right? It's going to come out as a 2. This is going to come out as a 2, all multiplying by itself. And whatever is left is going to end up staying in the house. Okay, so this is going to stay in as a 7. Okay?
So it's a 4 square root of 7.
Yes, yeah. So, Cuber, do you see how this works, dude? You see how, like, a 2 came out, another 2 came out, and we multiplied them together? Right? No?
No, I don't get it.
Okay, all right. It's okay, dude. All right. So, we had our number.
How would 2 2s come out as
Okay.
2?
Okay. 2 of these 2s comes out as a single 2. 2 of these 2s come out as a single 2. All right? And then you multiply them together. If you want to see like why this is, let me show you for a second. Okay. Remember that 112, right? Was basically all of these things multiplied together. Right? 2 times 2 times 2 times 2 times 7. Okay? Oh, do you need some water? Thanks, Sam. I definitely need some hydration. Yeah. And you can check this, right? If I do 2 times 2 times 2 times 2 times 7, I'll get 112. I mean, here, if you don't believe me, I'll put it on my calculator. You know. Right,
I
2.
want to ask you something, though.
What's up, dog?
How does that even help you get the whole number or the decimal of 10.58?
I'm going to show you, dude. Oh, wait, I put too many 2s in there.
Right, so
I fucked up.
16 times 7 is 112.
Yes. Yeah, that's another good one. Yeah, 60. Good. Okay. Yeah, let's do that. Yeah, let's do that instead. So instead of well, no, let's keep it as yeah, we can keep it as 16. So you want to say this is like 16 times 7? It's okay. Yeah. So really we're doing the square root of 16 times 7. We're 16. How can I write 16 as something squared? One sec, I gotta re-log in. We've been on here
Four?
for 4. Yeah, right. It's 4 squared, right? So I just gotta reload. Okay, right? Yeah. So here, what I'm gonna write instead, right, is I'm gonna say this is 4 squared times 7. Okay.
Okay.
Now, whenever I have the square root of a times b, that's the same thing as the square root of a times the square root of b. Okay? The square root of, like, square roots multiplied by each other is the same thing as the square root of them multiplied together.
Okay.
Have you seen this before? It's okay if you haven't.
No, but I think I get like why it is.
Okay. Good. Yeah, okay. So if I wanted to break this up, this is the same thing as the square root of 4 squared times the square root of 7. Okay? You see how I took the two things inside the house and I put them into separate houses?
Yeah.
Oh, wait, Dr. Go, you know what I realized?
What's up?
The 4 squared is just basically useless since it's just 4 itself.
Yeah, exactly. Yeah, exactly. That's the point I'm trying to show here. Okay.
Which-
Cuber, do you know what, like, the square root of something squared is?
No.
It just gets rid of it. So, square rooting something squared gets rid of the square root. So this goes away, and now you just have 4 root 7.
Okay.
Which do you see is the same thing here? Do you see how this is eventually like 4 root 7?
Oh yeah.
Yeah. So that's why it is. So we could have also broken up our tree this way if we wanted to. We could have done 1, 1, 12. And I could have done this as, what was this? 4 and 28. And then 4 and 7. Yeah, that's another way I could have done this. All right. You see I have a pair of 4s now?
Yeah.
Pair of 4s come outside the house. 7 goes inside the house. 4 root 7. It's the same shit as this.
Oh, okay.
That's what's happening when you're finding
the rule
pairs.
was, like, the
Yeah, go on.
Pair
Yeah, you
was all, the rule with the pair will always like apply.
Yeah, so anytime you got a pair, you're gonna pull it out, and the things you pull out multiply by each other. Okay, and then whatever's left goes back inside the house and also multiplies by each other. Yeah, well, ask me next time, Cuber.
What if,
go on.
You just did like 16 and 7 like right away.
Well, then I don't have any pairs, right? Okay, so yeah, let's say we did that. Let's say I did 1, 1, 12, right? And I did 16 and 7, right? I don't have any pairs right now, but I can, right, break up the 16 into a 4 and a 4. Now I have a pair. So here's the cool thing. Look, Cuber, I could either pull out a single 4, right? Or I could do this. See, I could break up the 4s into like 2 pairs of 2.
Yeah.
So then I can bring out a 2 and a 2, which is just also the same thing as just bringing out a single 4. Yeah. This is good. Like, ask me about this next time, Cuber, when you want to learn something. Let me go over this and like show you like more complicated things, because I think exponent rules would be really good for you to learn. And like square root stuff. Cool?
Yeah.
All right, nice. Good job, dude. Where's my clap? There we go. Nice, Cuber. Okay, cool. All right, I think that's all the questions for today. Let's close out the stream. Thank you, everyone, for coming to Office Hours. Had a really great time learning with all you guys. Appreciate all the questions. Appreciate Ethan helping me out with with students. Yeah. Cool stuff.
Well, I can leave now. I'm going to leave now.
Okay, it's okay. Yeah, so again, yeah, what's up, Cubes?
I think yesterday I didn't get my points for the 2,000 points for the tournament.
Oh, yeah, let me give those to you. Yeah, you're right. Let me give them to you right now. You're good, dude. There you go. Okay, what's up, Will? What's up, dog? You want to come to the stage? You want to say something real quick? Come say something, dog. Will Smith. Big Willie with it.
Yo. I
what's
just want
up?
to, like, this chemistry, I got, like, 200s in a row.
Yeah?
I just want to, like, say thank you.
Oh, dude, you're very welcome, dude. I appreciate that, man, dude. That's the best thing for me to hear, man. That like doing things on this stream that helped you out, yeah?
Yeah, it did.
Oh, fuck yeah, dude. Congrats, dude. Yeah. Keep getting great grades and shit, dude. Yeah, you're very welcome, man. Yeah, always come back, dude, if you ever have questions. I'm there to help you guys out. Fuck yeah, dude. I love that, dude. That's the best. Then I'm like, oh, this is worth it. Okay, sick, dude. All right, yes. So again, yeah, that's a beautiful example also, guys, why like you should ask questions on this stream. Like, let me help you get good grades in your classes. It's free here. We do this. We're a nonprofit. We're trying to help you guys out. So yeah, that's a Will Smith's a great example of like what happens if you ask questions, you'll do well in class. And also like I'm gonna buy you gift cards anyway, so like, you know, it's a win-win situation. Just need a little bit of a push. I had a student last night who's like, Dr. Gold, I'm gonna fail all my math classes. I'm not gonna graduate. And I was like, bro, I had no clue you were failing math. I'm like, you do realize the whole point of this Discord is to help you out with math? I mean, I have fun playing games and shit posting memes too, but like, you've been here for a couple of years, man, and you've never asked for help. Like, please ask for help. That's the whole point of this. Yes. So yeah, I appreciate that, Will Smith. That's cool, man.
Oh, another thing, like, I think I have enough coins for like the gift card. How do I like redeem
Fuck yeah.
it? Or
Yeah, just buy it in the store, and then ask one of the mods if you don't know how to do it, and then just send me a DM what you want, and I'll buy you it. Anything that's I can get on like GameStop or like Steam or like anything video game related. Just for it's for the fucking tax accountants. I have to like I can't show that I'm buying like Target gift cards because then they're like, what the hell are you buying the kids? I'm just like, I don't know, food. But yeah, just send me a DM what you want. I'll get it to you later today.
Alright, that.
You're welcome, dude. Yeah. All right, yes, awesome. Thanks again for coming to the stream. If you ever want to join our Discord, you know, and also earn prizes and ask your questions, that's where it is. Tax accountant. Yeah, I have to have someone who does our taxes. Yeah, although I'll probably just do our taxes, but because they're not that complicated yet. And also, yeah, if you want to follow some other like really cool math streamers, these are our friends. Go check them out. They run streams also all throughout the week on days that I don't. Because yeah, there's no stream on Thursday. That's my one break day. Friday I usually do an AMA, but I don't have anyone scheduled yet for this week. I may just do a bonus stream with myself. Let me see. Some girl said she was gonna take me out to lunch, but now she's like, dude, I can't with women, dude. Y'all gotta chill, man. What is she saying here? Also, just FYI, my job is very unpredictable, so if things get crazy and I have to rain check, please don't hate me. Like what? Okay, you know, cool. I don't know. Anyways, but yeah. Otherwise, our next stream will be on Monday. That's at the regular time, 3 p.m. Pacific, 5 p.m. Central, 6 p.m. Eastern. If you ever want to see when our schedule is, it's there. That's our schedule. You can join our Discord and find it out as well. Okay. Awesome. All right. Next thing we're going to do is I'm going to raid one of the other math streamers, science streamers, whoever else is streaming today. We love to, let's see, what do I do? Not Chads, I do live. Yeah, there we go. Oh, dude, everyone's live today. Awesome. Nice. Okay, let me see who I want to raid today. Oh, actually, no, I don't see anyone. Wait, it says they're live. Wait, that's wrong. They're not live. Okay. Ask a Scientist Gaming, Blonde Butterfly. Here, let's go say to go say hi to our buddies at Science. They're very cool. They do streams for all night, and they'll just talk about cool science stuff. It looks like they're doing a partner stream with Paleontologizing. He's a paleontologist who's very cool as well. So, yeah, go say hi to them. Say Dr. Gold sent you. And I will see you guys again on Monday for sure, and maybe Friday there'll be a bonus stream. I'll let you guys know. And then stay tuned for the weekend games we'll be doing. I'll make a post about that as well. All right. Have an amazing rest of your Wednesday, and I'll see you guys around. Peace.